Okay. Good morning, everybody. Now that you are suitably security briefed, I'll give you a quick introduction. So firstly, welcome to ESRIN, European Space Research Institute. I'm Gordon Campbell. It's Yolanda and Michaela that have been organising this from the ESRIN point of view. Okay, so just hopefully, does this work? Let's try this. No? How do I work this? This is a good start. There we go. Right, okay, so I've got the next 10 minutes. First, introduction to the European Space Agency. We're an intergovernment organisation with the member states up to the Swiss flag, and then plus Slovenia, and the other guys are cooperating states. We have an annual budget of about 7.8 billion, of which about I think it's somewhere between 20 and 30% is on Earth observation. And the idea is we're a way of cooperating between member states on space research and infrastructure. So doing things together that individual countries can't really do by themselves. There's about 5,500 of us distributed over different sites in Europe. This is the Italian site. We have a site, the biggest site is in Netherlands, near Amsterdam. We have a site in the UK where we do most of our telecoms activities, a site on space science data management in Spain, the Spacecraft Operations Control Centre in Darmstadt near Frankfurt, and our head office is in Paris. ESRIN, where you are here, we have, this is where the Director of Earth Observation sits. We also have launchers activities here. The Vega launcher is managed from here, and this is the site where a lot of the ESA administration and IT and things is managed. In Earth observation, we cover the whole range of activities, really. We build satellites. In fact, I mean, this is a sort of list of the different satellites we have. We have, I can't remember quite, we're building 3 classes of satellites and operating many of them. So scientific satellites addressing particular challenges in Earth system science. So, for example, we have a satellite running just now called SMOS, which is measuring very accurately soil moisture and ocean salinity. We have the Sentinel-1, 2, 3, etc., which are the main part of Copernicus. And we build, but don't operate, meteorological missions. So we've just we launched last year, I think it was, Meteosat 3rd generation with a new lightning imager, and we'll be launching next generation polar meteo satellites as well. The management of the missions we manage is done from here as well. So like I say, we're managing the scientific satellites and the Sentinel-1, 2, 3 for the Copernicus activities. Also here, in the same team, is the CalVal and data distribution. So we're distributing serious petabytes per day, not just linked to Copernicus, but increasingly the Earth system science. The Earth Explorer missions are providing larger and larger data, and we're seeing more and more uptake of these sorts of data, not just by particular scientific communities, but also wider communities as well. For example, we will be launching a satellite called FLEX, which is looking at solar-induced fluorescence next year, hopefully. And although that's really targeting looking at live biomass, if you like, there's a range of other applications in the community. We're expecting quite a big community for that. On the exploitation side, so we have a big team on Earth system science, applications development, pre-commercial development, etc., of a range of application domains. Some, not enough, but some activities already on cultural heritage. We would like to expand that, so it's great to have you here. We really want to be doing more on the cultural heritage side, also natural heritage as well. We're working on emergency response. The International Charter for Space and Major Disasters is managed out of here. We're working increasingly on digital twins, so both data digital twins, so having lots of data integrated in a consistent way, but also having these larger data sets as initial conditions and boundary conditions for some of the more complex Earth system models, so we can have digital twins for predictive analytics for things like climate forecasting or extreme events. And lastly, climate change. The main activities on climate change are managed from our place in the UK, but a lot of the actual scientific projects are managed here. So, for example, a lot of the essential climate variables, where Earth observation data is the main contributor, the development and verification of these activities. So sea level change, sea surface temperature, etc. That's all managed from here. We have the FELAB here as well, which is looking at more disrupt rather than normal application development. These guys are supposed to be looking at disruptive application development, so they're looking at things like quantum processing, large language models, etc., how these interact with Earth observation. And also, InCubed is managed out of the FELAB as well. That's a dedicated program on commercialization. So we take applications that have been developed and try and take them to market. So it's a different way of thinking. And that's managed by these guys as well. So that's what you've got here in Esren for Earth observation. Turning to natural and cultural heritage. So what's the connection between space and cultural heritage? Well, I think there's three different areas that we can be looking at. So these have been characterized into understanding, security, and benefiting. So for understanding, we're looking at land surface signatures associated with change that links to either the presence of features, the presence of structures that we're not aware of up until now, or better able to characterize what's happening around about sites of cultural heritage. Looking at threats to cultural heritage, so urban sprawl. We have problems with things like illegal waste dumping around cultural heritage sites as well, so monitoring these type of activities as well. Looking at how climate change indicators and changes in Earth system parameters around sites of cultural importance, how these are changing driven by climate change, and monitoring and detecting, monitoring the sites just for things like detecting looting, and also detection of buried sites that people don't know about until we're able to see some of the signatures from Earth observation. Securing, like say, monitoring and destruction or looting. Air pollution monitoring as well is a big issue in a lot of these sites, and other threats as well, like coastal erosion associated with some of the sites in coastal areas. And then increasingly, I think we are interested in how we can use Earth observation for the sort of economic characterization, so things like links between tourism, cultural heritage, etc. How can we foster that, as well as expanding the dissemination of the information associated with cultural heritage sites. There we go. Just some application examples very quickly. So this is what I was talking about before, at the start, just detecting signatures associated with buried sites. So this is an AI-based detection of anomalies associated with buried sites. This is in a sandy desert in Pakistan, but these type of signatures, or signatures of interest, can be in any type of land surface. It can be signatures on the vegetation health in arable areas. That's used a lot in Poland, for example. So any type of anomaly, any type of buried structure can give an anomalous signature for the vegetation, the soil, the sand, whatever, and that can be linked to cultural heritage sites. I think the AI in here as well is increasingly important, in particular for this community. We already have so much imagery from the Sentinels, there's not enough human eyes in the world to actually look at the data we've captured so far. We need AI to be processing these sorts of data sets, and in particular when you're looking for small features or small signature changes associated with buried structures, the AI is indispensable, I think, so we need to be really pushing that agenda as much as we can. Also, what we're doing here with this photo of the Vatican, the sort of capabilities we have for processing data, for data formats, etc., we can take these from the space domain and take them into the cultural heritage domain as well. So this was a big project we did with the Vatican for digitization of all the Vatican archives, using processing and formatting technologies coming from the space world. So it really enabled and brought the cost down to manageable levels, a massive digitization effort in the Vatican a few years ago. Other applications, so monitoring site destruction, so we know what's going on in areas where we can't go. If there's, this was areas where there's for example, a lot of violence. So it might be like deliberate terrorism, or just it's getting in the way. The site is getting in the way of armored cars and things like that. So just being able to understand that in areas where we can't physically go is important for planning of reconstruction and optimizing how we mitigate these sorts of threats. And then what we're saying before, so things like urban sprawl and tourism impact, this is increasingly a problem, in particular where we are in Italy. So the impact of people going to the cultural heritage sites. Obviously, we don't want to say everybody keep out, but all of this needs to be managed in a sustainable way. And this means not just Earth observation data, but how do we integrate Earth observation with other types of data that you're maybe not thinking of? So things like mobile phone data is not your personal data, you're still anonymized. The data are aggregated, but we can have aggregated data of how people are moving around, what the patterns of life, etc., and connect that to the Earth observation data so we can understand really how we sustainably manage these sites in a better way. I'm talking about looting as well, so this is a project called Alcio, done by IIT. So this is looking at detecting of signatures associated with looting. So it might be digging holes, it might be other changes, but this is increasingly an issue. And again, this is an end-to-end analysis as well. We're looking at the changes associated with the Earth observation that gives us a signature of looting, all the way up to the guys that have done the looting selling the artifacts on eBay. And we're looking at all the elements in between there. This is other applications. This is using polarimetric techniques. I mean, I think we don't do enough with polarimetry, in particular with SAR, and I think this is, cultural heritage is clearly a domain where polarimetry can make a nice impact. I think this is work done by Yolanda. So this is looking at polarimetric signatures of anomalies associated with buried structures that we don't see using normal data. So this is in Sudan, where we've not been able to validate this with a site visit yet, but we're hoping to send Yolanda at some point. So even advanced techniques like that, and there'll be more and more polarimetric SAR capabilities coming along. When this was done, I think we only had ALOS data. I mean, we'll have NISAR launched next year. It's going to be a game changer. It's got a duty cycle of 70%. It is always on. The volume of data you will have for looking at these sorts of sites as of next year is massive, so get ready. Okay, don't plan any summer holidays next year because you're going to be looking at NISAR SAR images. Okay, disaster risk as well. This type of thing can be monitored, and the mitigation support can rely heavily on Earth observation as well. We're talking about, for example, coastal erosion. So this is just down on the coast from here. So this is looking at down here at the bottom. This is coastal erosion threatening this roaming activity here. But it can be anything: forest fires, whatever. Earth observation is making a contribution to managing these sorts of things. On the natural heritage side, we're working an awful lot with the international conventions, as well as national environmental protection agencies, etc. But these are some of the big conventions that we're working with for natural heritage preservations. For example, Ramsar for wetlands, the Convention on Biodiversity to reduce loss of biodiversity, and also looking at how we integrate Earth observation into environmental accounting and natural capital characterization. Quickly just showing you some of the other analysis we can do, so we can look at the impact of the pandemic on tourism. There's some very easy signatures, so you look at the difference between a normal tourism day in Venice and a pandemic day, and with a few assumptions you can actually use these sorts of data to actually characterize the economic impact that on tourism that the pandemic is making. Some suggestions, initial suggestions to think about for how we're moving forward. So, like I was saying at the start, we really want to be doing more, in particular in the cultural heritage domain. So it's great that you're all here. Some of the issues we would like to see addressed include things like enhanced communication between the Earth observation guys and the cultural heritage guys. There is crossover, but it needs to be much, much more. And we need to be making the Earth observation data easier to use. We can't always have the complexity of Stokes matrices and all of these things. Archaeologists don't care about that sort of thing. We just want to see the stuff. Okay, so we need to find a way to get that communication accelerated and strengthened. And this means, user-ready products bridging the gap, embedding or better connecting the Earth observation with other data sets, and looking at how this is also integrated into cultural heritage management. If you're looking for a quick and dirty funding source, and you're in an ESA member state, we have something called our permanently open call. Okay, so this has a number of submission deadlines. It's got a submission deadline every 4 months. It's quick and dirty. Try it and see. Just try something out innovative. You can have up to 200K, which we're not throwing more money at it because we want you to focus on really the thing that you want to fix or try out. Okay, we can always throw more money at something with a bigger contract if you can get the innovative thing to work. Okay, so this is new stuff. You want to try it and see. 200K. It's there's a proposal template. Have a look on the ESA Star website, or contact Michela if you're interested, because it's designed for people that it's optimized for people that haven't done an activity with ESA before. If we look at the statistics, the success rate of guys that we've never heard of compared to guys that we have, it's the same. Okay, so it doesn't matter that you've not worked with ESA before. It is as equal as we've been able to make it. So have a look at that. If you're interested, also say, talk to Michela, talk to me. It's there as an opportunity to try stuff out, in particular in cultural heritage. And yeah, other things to think about. We've got a bunch of resources and tools. If you're looking for heavy processing, or if you're doing a project that needs heavy processing, we can cover the cost of that if the heavy processing is linked to Earth observation, so cloud-based processing, that type of thing. We have various other platforms that can do that for you. We also have processing software. Have a look at Snap if you're just doing normal image manipulation, Pulsar Pro if you're looking for the polarimetric stuff. Yolanda's an expert in Pulsar Pro. So these tools are there for you. And the other thing we do is training courses. Okay, so these are some of the training courses that we've already set up. But I mean, we have a team dedicated to providing training courses. So if that's something interesting for you as well, let's have a chat. And I think that's it. Thank you very much. Again, welcome to Esrin, and I hope you have a really interesting and fruitful and productive meeting, and lots of ideas for cultural heritage for projects to go forward. Thank you.
Good morning, ladies and gentlemen. It's a great pleasure for me to be here to represent Ursel. It is somehow jointed in the organization of this workshop. I have to thank very much Yolanda Patruno and Mario Hernandez, very good friend, for inviting me to represent Ursel in my position of Vice President of the association. Well, most was already said about the very important this initiative related to the support, the strong support of Earth Observation for cultural and natural heritage. I would say it is an evergreen topic, no end, instead very smart and strong development in the now and in the coming year for the availability of new sensors and the updating of methods and techniques. And we saw in the extremely nice presentation before what can be done using Earth observation products. But as already underlined, there is a growing, increasing need to transfer knowledge and to support authorities and institutions for monitoring and preservation, of course, against artificial and natural risks, and also to implement the valorization plans and sustainable tourism processes to make a good usage, a good knowledge of what is available for in the cultural and natural heritage, of course. And it has to be underlined also that there are strong connections to several UN SDGs related to our life. I just listed 4, but I think more than 4 are really connected out of the 17 SDGs. I would say that coming to Ursel attention to this topic dates back almost 2 decades. The first Ursel workshop was launched. It was on cultural heritage, but it was launched in Rome in 2008. And I also would like to stress how interdisciplinary is the topic of cultural heritage in the frame of Earth observation. There are a strong connection to many other fields that are investigated within ERSL. I don't want to read the list, but it is clear that cultural heritage, cultural and natural heritage management through Earth observation products and results is very important and very well connected to a lot of different fields. And within ERSL, it is of course important to have a special interest group that is very well chaired by Yolanda and Mario. So more info to this link. I would like also to stress the fact that ERSL would be very interesting to improve even more the initiative on this topic. And I only would like to bring to you some possible initiatives. That is, for example, data sharing, common data to work together on in different research and university institutions. To organize, it is standard, of course, for ERSL to organize symposia and workshops, but it is very important also to organize summer or winter school webinars in order to reach a big amount of potential interested users at different levels, not only researchers, but I would say that it is important to strengthen the connection with authorities, agencies in charge to maintain cultural and natural heritage. And also, it is important and it is very welcome, especially from the youngest researcher, to have hackathons on this topic, just to have the possibility to get new ideas. That is a standard in hackathons initiatives. I only would like to list, of course, not reading, but just to present you the next coming ERSL event. And I would like to stress that I was talking just a few minutes ago with Mario. In the next symposium, it is already planned, that will be held in Prague, it is already planned to have a session, maybe more than one, reserved to this topic that we are glad to discuss in these 2 days here. And also there are other events that are somehow connected, as I mentioned before, to the topic of cultural and natural heritage. So please feel free, really, they are very welcome. Feel free to share ideas and suggestions, and please keep in contact with ERSL. We have, there is a direct link with the Secretary of ERSL, and also we have a LinkedIn profile. In the end of my very short notes, I would like to thank especially Isa, that not only in these 2 days, but usually is very supportive of many ERSL initiatives, so many thanks, and I wish you a vibrant and fruitful workshop at ISA ERSL premises in Frascati. Thanks a lot.
Hello, so welcome to Heritage Meeting. Just very short logistic notes to let you know what's going on here. How is it? Okay. There you go. So we have 8 scientific sessions over the 2 days, 4 keynote speeches. The coffee breaks are in the James Cook, which is just right next door from us. Then we have lunch downstairs at the canteen, so just go down the stairs and you will find the canteen area. We have a reserved area, so if you see reserved tables, it's for us. You can use those, otherwise go wherever you want. We have a welcome drink tonight outside the terrace, so you can have some food and drinks and talk with your colleagues. Tomorrow we have arranged for a fee experience, which is over in the building 11, so you will be taking from outside of the Magellan, accompanied by our colleagues, to the building 11. You will be split in 3 groups, and you can visit the heritage, the fee experience, and what was the third one? Is the memorabilia wall. So that's the 3 things you have. Guidelines. If you haven't given your presentations yet, please come down to the Regia area where you can download your presentation, give it to the technician, and we will take care of putting it in the right folder. About the fee experience, I already told you. The shuttle bus, as you have noticed this afternoon, at the end of the icebreaker, you will be taking back with the shuttle bus. Tomorrow morning, you have the shuttle bus coming here again. And for tomorrow afternoon, when the event finishes, there is no shuttle bus. So if you need a taxi, please book it in advance, because it will be a problem to find it at the last moment. So if you can do it already today, you know you need a taxi, please go and book it already. We will have a group photo taking outside the terrace today before lunch. So after the session, the Q&A will be go out to the terrace, take the group photo, and then we will go to the lunch. So that's the logistics side. Thank you very much and have a great event.
Hello again, good morning. Hi. So welcome again to this workshop on cultural and natural heritage. Indeed, there are a few years we didn't get with this opportunity, so we are quite happy to have you today. And also for the people following us remotely. So my name is Yolanda Petruno. I work for the European Space Agency, and my background is actually in this domain. So I was formerly a supplementary data researcher, and specifically for the cultural heritage sector. And I have here my colleague Mario Hernandez. I will maybe leave the floor to him for a short presentation, and then we start with all the contributions.
Good morning. For me, it's more than a pleasure to be here, in particular to be in the premises of the European Space Agency. When I was working at UNESCO, we launched the open initiative on the use of space technologies to support World Heritage Sites. And the partner that was the stronger one was the European Space Agency. And since then, I think that the topic has taken up, and as a result, we're having here this workshop, and I'm seeing worldwide that is picking up and picking up. And so we should continue. I was very pleased to see in the ESA presentation that there are opportunities if you have ideas in order to start developing services. I think we are now in that stage where we can propose services. being the problem who is going to fund it, because heritage is always without funds, as far as I discussed with the authorities. And so let's start the workshop, and let's hear your research and your work.
Okay, so thank you, Mario. We will start then with the first presentation, Copernicus Land Monitoring Service, Global Earth Observation Products for Natural Heritage Monitoring, given by Simone Balbo. Thanks. Just a quick reminder, you have 15 minutes for your presentation. If you are able to be on time, then we can have a few questions. Otherwise, coffee breaks are always a good spot for all the questions.
Is this open? Okay. So, good morning, everyone. My name is Simone. Today, I will share my presentation with my colleague Andrea. So, thanks first of all to the chair and ESA for organizing all of this. I will talk to you about CLMS. So, this acronym is Copernicus Land Monitoring Service. And in particular, I will talk to you about the global products that could be used for monitoring natural heritage. Yeah. So I would like to take it from a broader perspective. I'm looking a bit around on the Copernicus material on the official site, and there I could see that already in 2018 there was it was published this article that you can still reach, and there you can see that the Copernicus program cares about this community of users and is aware of this community of users. And in particular, the statement is the data and information offered by the Copernicus can contribute to both tangible and natural cultural heritage preservation and management. So this is the key message for this slide. So Copernicus cares about this community of users. And going to land, which is one of the 6 services of the Copernicus, we as land service, we are more linked to natural heritage because of the nature of our data that we can offer. And so as a almost newbie in this type of applications, I had to start from scratch, from the definition. So we look at authorities there. UNESCO is our authority. So here is a definition of heritage, and this is why natural heritage is important for the land service, because it is so spread. I'm sure that most of you are very familiar with this data, spread with this size, the size of India, across 100 countries. So land service, being a global service, could really serve many of the applications in relation to natural heritage. Coming to the applications, again in the same article, there is a message that I think is important. So the key challenge already in 2018 was not the development of new types of space-based observation, but rather develop tailored products or services. And this is where research comes into play, and this is what I believe we are doing today also. I made a quick review on scientific articles, and I found a couple of interesting applications where land service could come into play. Maybe some of you are in this room. For example, we talked about transformation of barren lands into agricultural lands, and this is about land cover change, and this is one of the products that the service generates. And then the other example, thawing ground and coastal erosion. This is related to cryosphere, and this is another theme that the service monitors. So we believe that the land service can really contribute to downstream applications in the field of heritage. So just a few more details about the land service. It provides geographical information on land cover and changes, land use, vegetation state, water cycle, and energy variables. And the aim is to provide harmonized and consistent time series. the portfolio is very wide and is divided into groups. Groups are land cover and land use, priority area monitoring that we will see with Andrea later, satellite data, biogeophysical parameters, and ground motion monitoring. I think this is one of the most useful for this community of users. Quickly on the EEA, so land service is co-implemented by Environmental Agency and Joint Research Center where we work. At the EEA, the objective is pan-European coverage with high-resolution data. So if you're interested in European data, this is where you should look at. While at the GRC, we look at global extent with medium resolution. And I selected here and highlighted a few group of products that I believe that are relevant. So vegetation products, we monitor on a 10-daily basis vegetation biophysical variables such as photosynthetic activity, the density of plant canopies, the famous NDVI as well. So these are very relevant products for monitoring vegetation. And also I wanted to highlight also water products and cryosphere products because I believe this could be also relevant for this community of users. Now, in the next part of the talk, we will go more in details on the global land cover and the hotspot monitoring products. So I start by giving a bit of history about the land cover products that we generate at the land service. The history starts in 2017, where the first map was generated at 100 meters, covering Africa, only at the time. And the key part of this product is that there is a double type of classification. There is a discrete classification where every pixel in the map is characterized by a label with the land cover type. And what is probably more relevant here is the cover fraction layer. So every pixel is characterized by the proportional coverage of a specific cover type. And this is very useful for monitoring land cover types in mixed cover types. Then after 2017, the production with the new algorithms extended to global, and annual data from 2015 to 2019 were generated. We reached more than 20 classes on the discrete map, and for the continuous covers, we reached 10 continuous covers that you can see here in the slide. So this is what we have now available for working on land on heritage monitoring. But a look into the future, in the near future, in 2015, there will be the release of the land cover and forest monitoring product. And here we will have an unprecedented combination of spatial and temporal resolution. There will be an increased spatial resolution scaling from 100 meters to 10 meters based on Sentinel-2. There will be a global coverage, and most of all, there will be intermediate products for further analysis and processing. I'm talking about not only the annual products that are the ones at the top of this slide, so land cover map, land cover change map, which is something that may be more traditional, but the innovation here is the land cover characteristics and the land surface categories. For the first, it's about intermediate product, such as indicators such as NDVI and others vegetation variables, while for the land surface categories, we are talking about direct observable surface properties such as water and snow cover. This will be provided initially at a monthly temporal resolution, scaling down to 10 days and then on near real time. So the innovation for users is that maybe you will not need to start with your application from the Sentinel data. You could save some work and work on these intermediate products. So now I leave the floor to my colleague Andrea, who will explain a use case.
Thank you, Simone. I'm Andrea Lupi, consultant for Joint Research Center, European Commission, colleague of Simone. let's have now a look in detail on one of the CLMS product, that is the hotspot monitoring project. What it is a land cover and land cover change mapping project, which focus on specific areas of interest that are defined specifically for their biodiversity and natural interest, and requested with ad hoc request by institutions that could be European institutions as DGs, delegations around the world, and other European projects. Also, UNESCO is involved in this definition of the area of interest that want to be investigated at much defined detail in geographical and of, let's say, legend detail of classification. Until now, the hotspot, the first phase of hotspot project mapped 19 areas of interest, and the second phase of the project will be launched before the end of the year. It's now really in the kickoff setting of the next kickoff meeting. This is an overview of the areas mapped until now in the first phase. You see the key landscape for conservation areas that are, let's say, the areas defined as being of interest to be mapped in yellow, and the protected areas in orange, and what you see highlighted in the black striped highlight, let's see, these are the World Heritage Sites included in the key landscape for conservation area mapped until now. So all those areas are already mapped. We see here one of these areas, it's the Virunga key landscape for conservation areas. You see the results of, this is the 2019 land cover status mapping with the legend on the right, and on the left you see some charts giving you an overview of the class distribution. Let's say inside, the first on the top is inside the World Heritage protected areas. In the middle, the protected areas that are outside the World Heritage, so still protected areas, but not under the World Heritage UNESCO protection. And the last one down is outside, so outside the protected areas. So we are talking about areas surrounding, somehow buffer in a buffered area that is, I mean, those areas are very useful to understand the pressure in the really near surroundings of the protected areas. That is sometimes something that when you look into the protected areas, let's say status and land cover change events, sometimes you miss what is happening just outside of the border of the protected areas. So you see, look into the chart, how the natural forest closed classes mostly tends to decrease, giving space to, let's say, much degraded natural vegetation as a shrub or forest open, or even to agriculture. We see now, on the left, you see the land cover change explorer, which is the website on where we published all the results of the project. And we will see now, let's say, an overview, a further specific study done on the Nyiragongo area of interest. It is south of the Virunga key landscape for conservation areas. It is around a volcano, Nyiragongo. It is still also protected by the Natural World Heritage of UNESCO. And it's a special case of let's say, land cover change investigation we did, let's say, using as a basis the hotspot project land cover classes as a base of starting in order to further to up to date the analysis. So you see in the chart, in the bar chart, the evolution is a bit small, but the evolution is for the classes in a timeline starting from July 2022 in blue and going to yellow. The most recent date of observation is February 2024. And we observed a decrease of the forest clause giving space to the shrubland. This is a special case, a particular case of, let's say, endangered of the natural heritage involved by a crisis of refugees involved by conflicts in this area. Let's go further. Yeah, now just a couple of other okay, very fast. This is the DOPA services page. Here also you see on the right the same area, Virunga area, that is included as with the hotspot data inside this project, but you can find a lot of further information on climate, ecosystems, and this is valid for all the protected areas at all the IUCN levels of protection and worldwide. The second project tool, let's say, also developed in JRC is the African Knowledge Platform. This is now focusing only on Africa, but it is, let's call it a gateway to the data and the information on different aspects, also on social, economic, territorial, environmental data, and you can overlay let's say, the geographical data and extract with also tools and also other instruments, a lot of information useful to observe, also in this case, the natural World Heritage sites. Concluding, we can say that the CLMS products, the Copernicus, are definitely useful to help on assessing, monitoring, and reporting, mainly on land cover change. This is also the specific aim of the hotspot project. It is good for observe also the surrounding of the protected areas and the natural World Heritage sites. And again, the second phase will be launched before the end of the year. And what is special, last thing I want to say is that the CLMS products provide, being operational services, provide continuity of the products, giving, let's say, from the past to the future, a durable and accessible set of data, allowing users to develop their own downstream application based on those data that are free and available for the public. Thank you.
Any questions, please?
Thank you. My name is Cristian Milanov. I'm coming from Bulgaria. Thank you for the presentation. It's a little bit disappointing for me that we are speaking about Africa, India, Latin America, not about Europe. But I have one question. Are you using for the land cover Corine classification or the new world standard, ISO 9140? 4, 2, 3, and 4.
Yeah, I can take this one. Yeah, thanks for your question. As I don't know if I can go back, maybe later during a talk, during a chat. So the land service is implemented by two entrusted entities. So in JRC, Joint Research Center, we work on global extent with lower resolution, while at a European Environmental Agency, it's more about pan-European data with high resolution. So if you look at European areas, European Environmental Agency is the right and trusted entity, and yes, one of the most important products there generated there is the Corine cover, very famous and very wide application. But not only that is a very good starting point, but there are also very innovative products for monitoring vegetation, if you're interested in vegetated area. And these are the high resolution layers and also the vegetation indices that are generated every 10 days. So with Corine, you have an update every 3 years, more or less. But with these innovative products, you can have a 10 daily monitoring of your vegetation properties.
Any other question? Okay. The next presentation will be a remote presentation, and it's about the assessment of archaeological mounds with satellite, optical, and SAR-based high-resolution data. Let's see the logistics. There we have our friend Deodato.
Hi, good morning. I don't know if you hear me. I can hear you.
Yes, we hear you.
Okay, so good morning, everyone. It's my pleasure to open this technical session about the use of regional scale mapping products generated from both optical and radar data to map archaeological mounds. So just a bit of a context, archaeological mounds in North Africa and particularly the Middle East area are basically what in Arabic we refer to tells. They are topographic features. They could be either geological deposition or, most importantly, human deposition of a large amount of materials that could be formed over centuries as a result of different phases of settlement, destruction, weathering, reuse, and reconstruction. In the Near and Middle Eastern archaeological landscapes, these features are very prominent, so they have been used also in the 20th century as ideal position for having a long-range visibility across these landscapes. This unfortunately in some way caused some destruction and deterioration, and on the other side we had a very good mapping in the 19th century already in all topographic maps. So I have just recalled some of the earliest and most recent studies just to say that LiDAR data, SRTM and multispectral data have been used over the past 15 years. So there's a full scope to understand how newer data obtained from satellite could help us to better document and monitor the conservation of these archaeological mounds, especially across wider region. That could be quite inaccessible or costly to survey, or in some cases also due to security reason unfeasible to inspect. So we wanted to understand how higher resolution satellite-derived DMs could help in this respect, given that so far archaeologists have been using the 30-meter SRTM and the 30-meter product delivered for free by ALOS mission. So we started with Cosmos Skymed, the synthetic aperture radar data collected by the Italian Space Agency constellation, we achieved using 3-meter spatial resolution strip MapSAR images, 10-meter posting digital elevation model. Just to recall that the Cosmos Skymed constellation is made nowadays of 5 satellites. 2 of them are positioned on the same orbital plane in a way that they collect data every 1 day. So there's a 1 day gap in between, which is very helpful, especially in areas like in Iraq, which is the geographic area of our experiment, where we have also agricultural activity that could cause temporal decorrelation and loss of coherence. Already with this product generated with our own data, we improved significantly the level of detail compared to the ALOS digital surface model. I'm very pleased that during this European Space Agency workshop also to report about the use of Cartosat-1 Euromaps 3D DSM that was accessed through an ESA Category 1 project. We thank ESA for this opportunity, allowing us to access this product, which is available, as you see in the bottom left from the map, available across various regions in the world that are quite rich in archaeological heritage, and they are produced from Israel, Cartosat-1 satellite imagery. In this case, we are dealing with digital surface model from optical data. And again, you see on the bottom right, the improved quality achieved with this product, 5-meter spatial resolution. So using these 2 products, one developed by our own with our data, and the other one available through ESA Category 1 project, we were able to understand how to perform a morphometry of archaeological tells. In this slide, you see a sketch outlining the measurements that we are able to estimate using satellite-derived DEMs, accounting for the irregularity and the uneven condition of the archaeological tells. We can state that more or less 2 major categories could be identified. This is an example of the first category, so well-preserved tells. In this case, you see very well how moving from Sentinel-2 data across Cosmos Skymed data, we see very distinctively conical shape of our tell, so basically showing the good condition of this tell. The second category unfortunately relates to disturbed tells. You see pretty well in this example how the activity due to human action has caused partial leveling and flattening of these tell. So it's evident from all the data that the tell has been disturbed. So using these 2 main categories and of course all the nuances in between, we were able to inspect from remote a wide area in the Wazit Governorate in Iraq. It's interesting that the selection of these area was justified because in 2021 there was only a partial mapping available as an open access data. We were already aware from archaeologists that this area contains many more sites. You see in this map the coverage of the Cosmos Skymed, the strip map data that they provide 30 by 30 kilometer, let's say, swath more or less, and the matching overlapping area allows you to cover even more, and the Cartosat digital surface model dataset that was provided by ESA. So in total, the area that has been inspected using both data is more than 800 square kilometers. So you can understand how satellite data are very helpful to inspect such wide area. The results we achieved using these two data sets a total of 344 mapped tells that we are sure based on morphology, properties, and also the information from archaeological surveys that they are anthropogenic, or even if they started as a natural topographic reliefs, they have been inhabited over centuries. So we improved by 10 times the existing databases that I was mentioning and recalling in the previous slides, either published in archaeological survey reports, such as the one by Lipolis, or the available ancient Near Eastern tell mapping produced by Pedersen and provided for free. We were able, because we perform morphometry, also to assess their morphology, their shape, so we could perform some statistics that they can be very helpful for archaeologists. And some of them are also arranged as clusters. As you can see, for example, with this alignment, basically crossing the study area in Wazit, because not surprisingly, several these tells were expanded and inhabited along ancient watercourses. Some comparison between the digital surface model datasets available. Here in these slides, you see that elevation differences that we observed between Cartosat-1 and the other digital models are extremely low. No systematic shift has been observed. I also recall at the end of this presentation the fully open access paper where you can access the full metrics of these comparisons and accuracy assessment. What's interesting is that the derived heights for the whole set of 344 tells are similarly distributed, meaning that there's a very good cross-reference between the various data sets that we have been compared. This slide is particularly important because, as I will show you in a second in the next slides, some of these tells, unfortunately, are disappearing and some have already disappeared. So it's a question to be able to saying something about the disappeared site, as well as the sites that are still present in the landscape. We were able to derive these relationships between the area, the height, and the volume. So both with Cartosat-1 and Cosmos Skymed data, given the abundant sample that we are able to inspect from remote, we could derive these relationships that can help also to infer the size and the volume of other tells and see if newly mapped tells could fit with these relationships. The key point is that even if a site is not there anymore because it was completely level or flattened, because the Cartosat-1 and the Cosmos Skymed based maps of archaeological tells could be analyzed in relation to what has been observed in the 60s using corona imagery, so the declassified spy satellite imagery from the US that basically collected this landscape well before major human activities happened. We are able, based on the area, So the basal area that is still visible in the corona imagery, using this relationship to back analyze the data and hypothesize the volume of the tiles that have been already disappeared. And so this is precisely what we can do. This is quite important because this is a landscape that witnesses several anthropogenic actions threatening the conservation of archaeological tiles. You see from the various maps that we move across reworking and reshaping and leveling and flattening, which typically correlates well with agriculture, because agriculture is the driver to level and flatten these sites, although we have observed several cases where agricultural activity just border the archaeological sites. So we have a mixture of this situation, but in several cases, and I will show you some examples, agriculture leads to total flattening and leveling. There's of course looting, and this I'm afraid correlates very well with the presence of not only agricultural activity and modern development, but also the presence of road construction, so infrastructure that could help to access better these sites. There are also some other activities such as disturbance by heavy vehicles, and this is because these areas are not protected. So it's very frequent to see in the images both optical and radar data to see heavy vehicle tracks crossing these sites. I here show you an example of what I was referring to with reshaping, reworking, flattening, and leveling. So basically in the corona imagery back in the 60s, we were able to pretty distinctively see the footprint of these couple of tiles. But soon after, in the following decades, and more importantly, in the last 15 years, we have seen total destruction and reshaping of these tiles as a result also of agricultural activity and earth removal. And as you can see, also combining different data sets, we are able to see the changes. So it's very important to match this data in a multi-temporal view. This is another example just to show you visually what I was referring to before. In corona imagery, we saw very distinctively 3 sites, and these 3 sites are nowadays gone. But based on those relationships between area, height, and volume, because we know from corona imagery the basal area, we are at least able to estimate their volume. With this data, we are able to perform more automatic morphometric analysis, including the topographic position index and the deviation from mean elevation index, and both these indexes are able to improve the detectability of archaeological mounds. Although I have to say that the topographic position index in this particular case was more selective than the deviation from mean elevation, as you can perceive also from the top right maps, because you have also to consider that this is an agricultural exploited area, so some topographic reliefs are related to the levees and the canals used to irrigate these areas.
Sorry, Deodato, can you hear me? Deodato, sorry. Yes, we are running out of time, so if you can, okay, your conclusive remarks.
Yeah, I'm just at conclusive remarks. So, yeah, thank you. So you saw these 2 data are able together to provide various informations. Cartoson-1 DSM could be accessed free from, for example, from the ESA third-party mission category 1 program. Cosmos Skyme DMs can be generated using Cosmos climate data that can be accessed for free by national and international users by asking directly ASI for scientific research. So you are very welcome to contact us. With Cosmos climate data, we proved that the clouds standing out for more than 4 meters can be observed and mapped, and Cartosat digital surface model relates very well with these other available data sets. The morphometric analysis led us, as I showed you, also to say something with regard to vanished and disappeared towns. Of course, there's an intrinsic limitation. We still need archaeological expertise because a mound could be natural or anthropogenic. So it's always fundamental that this morphometric analysis is used also to support and integrate with archaeological interpretation. And here you see recall that the two projects wherein we developed this data and we performed these experiments, and the fully open access papers that you are very welcome to access and read. And thank you very much.
Thank you, thank you very much. I'm afraid we don't have time for questions, but of course, if you stay connected, we can have the question and answer around 1 p.m. So if you have questions, just remind your questions and then we can discuss it later. Thank you.
Thank you.
So now we move to the next presentation, which is Geoheritage to Support Heritage Authorities, research case studies on Maya archaeological sites. So we move a bit outside of Europe, and we'll be given by Mario Hernandez.
They are searching for my presentation. Wow. There we are. So again, good morning. I called your attention that here we have first my name, Philippe de Meyer, Lux Svartius, and then we have two archaeologists from Mexico. So because they are part of the team, we need to work with them in order to understand their requirements. I would like to start. Last year, I was invited to write an article for the book 50 Years of World Heritage Convention. And they invited me to write on the modern technologies. And the people that invited me, they were surprised to see that we are bringing a positive aspect of modern technologies. More, the chapter was basically the bad aspect of modern technologies as a threat for heritage, and so we convinced them that there is a benefit for heritage in what we're doing. To show a little bit the changes, this is when the World Heritage Convention was approved in UNESCO. And now with modern technologies, you can have a totally different type of meeting. It's today very easy to communicate and share, and unfortunately, everybody wants to share a picture of Venice and make everybody jealous so that they would like to go again to Venice and take exactly the same picture. And they are not interested in Venice. They are interested in taking the picture and sharing it as fast as possible in the Wi-Fi of the bus. Social media is modern technology, but it's also affecting heritage. New technologies can construct very big cruisers with, suddenly you have almost 9,000 people that arrive to the site. And we have low-cost flight that maybe you have experienced it. Sometimes when you arrive to the airport, the taxi is more expensive than the flight that you have paid. And this is a threat for heritage, obviously. According to the archaeologists, now Chichen Itza is receiving much more visitors than the Mayas that were living there. And I was recently in a workshop in Florence, and it was impossible to go out of the hotel. You needed to know if you wanted to go to the left or the right because the crowd was going to conduct you. And so that's why for that book, we proposed Geoheritage. I mentioned this morning that we launched with ESA the Open Initiative on Space Technologies for Heritage. But people were asking me, what is space technology? So if we are more scientific, we're now trying to call it geoheritage, which is basically geomatics. And it's everything that is dealing with your reference data, that is what we need in order to support the heritage authorities. I would like to show the first project that we did with ESA, with UNESCO, was precisely for the Virunga sites in Congo. There was a question why the project that was presented is working in Europe, but the sites in Congo are a hot topic for UNESCO. They are really threatened. And so the heritage authorities didn't have maps, and thanks to ESA, we were able to give them the maps for the first time. Very difficult to tell someone you are illegally logging into the site if you don't have a map. And so the map was really a big thing. It was done by Ghent University and won an award of being the best cartography of the year. Now I'm going to move to what I would like to show to you. We have been working in 3 of the many sites that are there. And this is good news for remote sensing because archaeologists in all the Maya world are detecting that there are not only pyramids, that there were big cities joining the pyramids. And so only with remote sensing you can really understand the cultural landscape of the sites that were constructed. And soon we're going to start working on a new site where they're asking us to make the cartography of the site. So these are the 2 main sites. To the left, Etna, to the right, Uxmal, where we have been working. And the new archaeological research is showing that Uxmal is linked with Keva and Lepna. And again, this is good news for remote sensing because then we need to monitor the whole area, which are big areas there. Etna is 25 square kilometers open to the public, but the site is much bigger. Only 10% is cleaned of vegetation, and that was the first requirement. Can we help them with the cleaning of vegetation? So we decided to do for them a 3D model so that they could see some of the structures behind the vegetation in order to facilitate the cleaning. So here to the left, you can see one of the drones that Ghent University is flying. And this is, if this works, I think doesn't want to work there. Well, it's a video that shows the 3D model, unfortunately. How do we work? We work jointly with the archaeologists. Sometimes I spent, being retired, it's quite easy, 1 or 2 weeks with them. And by looking at them, we're identifying how, with remote sensing, we can help them. And then the challenge is how to identify those topics that they need in order to make something interesting for the students to obtain a master's degree or a PhD degree. So it's an interesting combination. Not all the time it works, but it's quite good. Obviously, we do a transfer of technology, but by transfer, I don't mean that they need to become remote sensing experts, but they need to obtain a certain awareness of what remote sensing can do. We try to establish a local interdisciplinary network in the projects to provide them easy access to derive information and to identify which national services they could hire so that we try to provide the whole solution. And as I mentioned early in the morning, knowing that there are no funds for heritage, that already their work, they don't have enough funds to do their normal work, so very difficult to hire remote sensing services. That's why they like to work with us, because we work with students, and students with pizzas, you can pay their salary and start continuing doing very good work. This, if this works, is the video that shows how the main monument was cleaned using our 3D model. So previously, only one side was without vegetation. All the other 3 sides were totally covered by trees. And then that's why we flew the drones. We created a 3D model. We created several 3D models in order to show the advances of cleaning the vegetation. and then it comes the cleaning of the main monument. Now, if I move a little bit to Uxmal, the first question that they ask us is, we are identifying a wall around the heritage site. Can you help us mapping the wall? And we flew infrared drones, and we were able to monitor most of the segments of the wall. The rest were completed by the archaeologists. I'm going to move to the next project, which is in Uxmal. Basically, no, a little bit. Oops.
Bit of
I
suspense.
think-
Yes, for just.
Ah.
I think it's coming. Okay.
Oh. A little more. Yeah. So Uxmal has a problem. And basically, tourists arrive, they spend 2 hours there, and then they go back to the bus, and they go to another city. And the local people, that is really very poor people, they don't see any benefit. And fortunately, the site manager is very interested in bringing some benefit to the local people so that the local people can appreciate the fact of having a site. And he is developing tourist services. So we decided to help him with a very simple tool. It's a very nice area, has really lots of attractive points, very easy to spend 3 days there, cycling into the forest and sleeping with the locals and seeing all the local handcrafts and that. And so with students, we develop an app, very simple, does not need to have telephone signal because in the area you don't have. And with that, the locals are now capturing points of interest for tourists. And then with satellite images, we're making the maps for them that will be the tourist maps so that they can offer services in order to see if the tourists really are going to stay 3 days in the place. So they do the data capture to the right. Then when they go to the site, there is where they have internet. They download the data. It goes to Ghent University. And there we applied artificial intelligence, geometric corrections, and we put the satellite layers, and then we send them a PDF file that can be printed locally. So this is a simulation, but it's more or less how we are starting to do it with them. And so if they really obtain a benefit, the heritage can provide an economical benefit, and they will then do more to attract to preserve the heritage sites. And so in that case, these young people could have a better future. We tried to do it bringing a group of adults from Belgium. There's the alumni group from Ghent University. And we face the problem that everything is pre-arranged by the mafia of travel agencies. So even with Belgium, it was very difficult to convince them, let's use the local as guides. They wanted to use pre-established travel agencies. They didn't trust the locals. So it's a problem to break that mafia of tourist services. And so basically, there are lots of undiscovered sites that were making part of the tourist guides and the tourist tour. And basically, that is my presentation. I will be around if you have questions, but thank you for your attention.
So thank you, Mario. We have time for one question, if somebody wants. Otherwise, we move to the next presentation. Okay. I think we can move. Thank you.
So the next The next topic by Laetitia Thirion is going to be identification of Maya ruins covered by the jungle using Sentinel-2. So we remain in the Yucatan area.
Thank you, Mr. Chairman, for this introduction. So yes, my name is Laetitia Thirion. I'm a professor at Centrale Supélec, which is a part of the University Paris-Saclay. And I am here with my colleague, Régis Guinvard, also a professor at this school. And we do our research in a French and Singaporean lab called Sondra, which is dedicated to the Earth observation using radar systems. So I am pleased to be here to present our latest results concerning the identification of Maya ruins covered by jungle using Sentinel-1. I have to tell that this work has been done in the framework of a PhD student who is Florent Micheneau, and we benefited from the help of Dr. Israel Inostroza, also from our lab. I take this opportunity also to thank all the organizers for this invitation. So the context. Actually, we would like to find some Maya's temple which are covered by vegetation. Let's say that it's our dream goal. And typically, we begin by this kind of observation. From the sky, we see nothing, only trees. And we know, because people tell us that, okay, we have some temples below. I don't know in which shape they are in general, but we expect that they are covered by soil, bushes, and trees so that we cannot see them from the sky. So typically, we would like to find a solution, but unfortunately it appears that archaeologists find a powerful tool, LiDAR, and from this kind of observation, they obtained, using LiDAR data, this kind of results. They fully removed the trees cover, and then they obtained this topographic map, and we can see, I guess, some temples or some buildings below. So maybe you could think that I have to stop my presentation here because everything has been done, but we guess that we have something to bring. Despite the high resolution of these LiDAR maps. And typically, drawbacks of this method is the fact that, you know that, I think, it covers only small surfaces, and it comes with a cost due to the acquisition and the process of this data. So what we would like to show you is that we could benefit from Sentinel-1 data actually to look for these temples, but at a wider scale. And it's interesting to use this data because we have a huge coverage, actually, of the whole Earth at a regular period. These data are completely free, and I understood that it was a real problem for this community. And using radar, because Sentinel-1 is a radar sensor, we could penetrate through foliage. I have to mention here that Sentinel-1 is not the best frequency to penetrate through foliage, but okay, we will tell about this later in the presentation. The problem with radar data is that they are not often used because they are quite difficult to interpret. This is an example of a SAR image, synthetic aperture radar image. And clearly, apart the fact that it is a sum of pixel, black and white pixels, it's quite difficult to tell what you're looking at. And in addition, you need to be quite an expert to process this data. So maybe it could explain why people do not use them a lot. And if you're fortunate and if you manage to get something, actually at the end, if you use Sentinel-1 data at least, you will obtain a data with 10-meter pixel size, which I think it cannot compete with your LiDAR data. But okay, we bet that with Sentinel-1, we could propose a first-step detection at a wide scale, and if we have some suspicion of detection, then you can organize a campaign, an in-situ one or a LiDAR campaign, in order to determine if you have truly building Maya's temple below this foliage. So actually, we rely on the anisotropic signature of these temples. So typically, if you look at the forest from, let's say, a direction or another, from a SAR image point of view, you will see the same thing. So no difference. We could say that the forest has an isotropic signature. If you look now at a temple, if you look at it from the west or from the east, you won't see the same thing. So it's typically this kind of characteristics that we will use in order to detect, to make the differentiation between foliage and temples. I said that Sentinel-1 was not the best one to penetrate. Let me explain a little. At C-band, which is a frequency band of Sentinel-1, you have a wavelength which is around, let's say, 5 centimeters. We could say that this wavelength is a kind of rule in order to look at your object. So typically, with 5 centimeters, you may expect to see twigs, leaves, but actually these objects will block your wave, and that's why it is not the best frequency you could choose in order to penetrate. But actually, we have seen some detection possibilities, capabilities with higher frequencies, and it is because of the holes you may have inside the forest. And typically, we expect to have some holes, or let's say some dense forest, because we have buildings below. So another point you have to know about Sentinel-1 is the fact that it is a right-side looking satellite when ascending in ascending direction. So it means that when it goes like this, it looks on the right. But because the Earth is also rotating at the same time, it means that the same position will be seen actually from a west point of view and an east point of view. So this will allow us to have two different points of view of the same site and to use our anisotropic or isotropic characteristics. So an example. Just imagine that you have a building and it is observed in the west case. Actually, for the SAR, the best contribution will come from these red arrows, which means a direct contribution from the roof and a contribution from the facade and the ground. So in this case, you will have high intensity contribution. While for this part and this part, actually, you will have a contribution that will be reflected on the ground, more or less, of course, but let's say that it is the main direction so that less intensity will go back to the sensor. The right part of the building will be in the shadow of the sensor, so nothing will contribute, let's say, to the satellite. For the east case, it's similar, but it is the opposite. Here, the left part was contributing in the west case, but now it is in the shadow, while for the right part now, the main contribution comes from this roof and this facade. And again, this part do not contribute a lot to the sensor. An application, an easy one, I choose something which is not covered by vegetation to lower my problem. And this is the Pyramid of the Sun in Mexico. This is an optical image. This is a side view. And you remember my SAR image? It was an image of this pyramid. And actually, from the west case, you can see that this part, which is very bright, actually contributes the most to my satellite, while the opposite facade is completely dark, which means that actually it's in the shadow of my sensor. Now, when Sentinel-1 is in descending mode for this region, then it is the opposite. This right facade contributes a lot, while the opposite facade is in the shadow. So now you have seen this. How may I combine these two observations? If I call I ascending and I descending the intensity collected by my sensor in ascending and descending modes, then I could make a division of these two intensities, a ratio, and I will obtain this third image. So I have selected 4 areas. Let's begin by area 1 and area 4. In this case, you have low intensity divided by low intensity. You have something, let's say, more or less equal to 1, and we've decided to code it in green. Here, for area 2, I have high intensity divided by very low intensity, and we have a strong response, we decide to code it in red. For area 3, it's the opposite. We have very low intensity divided by high intensity, a very weak signal coded in blue, and I already explained area 4. Let's go back to our example over the pyramid of the sun. So our 2 images and the final product. You understand that here you recognize very well the pyramid, while on the third image it was quite difficult to see. And if you look at this part, it is in red because it is seen mostly in the ascending mode, while in blue it is mostly seen in the descending mode, and in green you have all the areas that contribute equally to these 2 acquisitions. So we preserve the shape, we preserve the dimensions, we can obtain quite a lot of information from this data. Now let's turn to our sites. We have 3 sites, known sites, which are fully covered by vegetation, and we try to apply this. Here you have an optical image. We almost see nothing. This is our result product. And we have superimposed the contour coming from a map published in 1981. So I guess the shift came from the fact that maybe the accuracy of the location was not as good as we could have now. But let's say that typically we have this signature here and this signature here, which seems to correspond to buildings. But if you want to better understand how I can interpret this data, I propose to look at this scheme just below. I represent a plateau with, let's say, it's a side view with a swimming pool and a building, and I have my 2 ascending and descending mode satellites. Just imagine that I'm using the ascending mode satellite. I coded in red what I can see only in this ascending mode. Then, if I use my descending satellite, I can see only, this part or the part that I can see only in descending mode. If I now combine the 2, I will obtain this response. So in green, everything is seen by both satellites. In red, I can see this part only using my ascending satellite, and in blue, the part which I can only see by my descending satellite. This is a top view of this scheme. I did this because I would like you to understand that sometimes I may have an isolated red response or an isolated blue response, and sometimes I may have combined response of blue and red responses. You may understand that also, you may note that I have blue plus red if I have something which corresponds to a hole, and I have red plus blue if I have something corresponding to something which comes with a height. So now, if we try to look at our image, actually here and here, I have a building listed in this article. It corresponds here to a pyramid of 75 meter side, and here to a huge platform of 100 meter side. So let's say that we are quite good for these buildings. Now, if I look at this area, it seems that as my right part of my plateau, it corresponds maybe to a topographic effect that I can see at the border of the forest. Okay. Here for this building, we are not sure, maybe it's a building that corresponds to a plateau, but actually we do not have the information on the article. We are not archaeologists, so we clearly are not able to validate further our results. So we have some good evidence that our tool works quite well, but we cannot confirm it for all the buildings. And even if we have this map, we don't know if it corresponds to something which is still visible, and if it is still visible, in what shape are these buildings. Site 2. I forgot to mention the site. Sorry, it was Lamane in Belize, and here we are in Guatemala with El Mirador. So again, it's fully covered by vegetation. we can guess that here there is a topographic effect. And here this is our product, and here the same image, but we have superimposed a map coming from this article. Actually, I have surrounded in orange all the signature corresponding to a building. So meaning I have a red plus blue signature. So here I have identified 1, 2, 3, 4, 5, 6, 7, let's say easy 7 buildings. And some of them are already available on Google Maps. So, okay, I know that probably this is correct. And here I can see a large topographic effect that I guess corresponds to this thing. Now, if we go to the map from this article, we can see that here we have a building, a building, a building. So, okay, but for most of the buildings, actually, we cannot tell that we have a good detection. But we can see that we have some signature, but okay, we are not sure that we can relate them to buildings. So here again, we suffer from the same problem. Yes, we identify clearly some buildings, but we cannot tell that we are able to identify all the buildings, and maybe it's just because we are not able to have the correct information for in situ data, or maybe it can be also linked to the resolution that we have. Finally, the third site, covered by vegetation, we have some maps coming from, some indication coming from this person. Again, our product, we can see that we have identified correctly some buildings, which are here, and the same conclusion, and sorry, it was El Tintal site in Guatemala. So for our conclusion, so we have developed a tool which is able to detect clearly buildings below vegetation using their anisotropic signature. This tool is really advantageous because it's used only free data from ESA Sentinel-1. It's true that an expert processing is needed, but actually we have published this work, so it is available, and we are here to answer your question. The resolution is not probably the optimal one for you, but actually you can couple it with additional in situ data. Okay, I hope we can go further together if we could share your expertise. Thank you.
So thank you, Laetitia, for your presentation. Time for one question, if there are some. No? I have some, maybe later. Okay. Yes, thanks. Okay, so we can move to the next one and the last one before the coffee break. So the next presentation is from Forest Monitoring into Cultural Heritage, reanalyzing LiDAR data with deep learning to map ancient structures in Yucatan, Mexico. Will be given by Tim van der Voort. I'm not sure about the pronunciation, sorry. Thank you.
Yes, good morning. For the moment we stay in Yucatan, Mexico, I think. It seems to be a theme of this morning. Well, in my presentation, I'm going to talk about how we used LiDAR data that was not necessarily or not explicitly ordered to observe archaeological sites, but rather existing data from other projects related to forest monitoring in Mexico. And we use them to visualize archaeological structures and also try to identify them in an automatic way using some machine learning algorithms. The work I present here is not my work, so it's the work actually of two other people. First of all, it was partly funded by the Belgian Science Policy Office in a kind of demonstration case of how EO data could be used for such purposes. It was carried out by Jana Ameijer, who was a research assistant at the time at our university, Ghent University. But now she's doing more teaching and she has left this field. And the other one, Rune van Severen, was a master's student who did work on the deep learning part for his master's thesis. But he left university to work in the private sector, which is more lucrative, apparently so. That's why I'm stuck here now to present their work, but I will happily do it. So, well, the objective indeed was to investigate how we could use off-the-shelf, more or less deep learning models, faster RCNN, so object detection models, and also object segmentation models to detect and segment these archaeological structures, specifically located in the Puc region of Yucatan, Mexico. I'm not sure there is a laser pointer. Yes, there is. So there is two types of structures the student focused on. One of them is the typical building type of structures you have in this area. Not necessarily temples, also civic infrastructure, buildings, platforms, and so on. And the second one is a circular fire pits, which you obviously see if you look at the data. So the area, indeed, Yucatan, it's a well-known area. We saw it before. It's in the southeast of Mexico. What is well-known is Cancun for its beaches. The major sites like Chichen Itza, Tulum, everybody knows them. But actually, as was mentioned before, there is much, much more there because there was a lot of settlements in the late terminal classical period, 600 to 950 AD, located there. Before they were abandoned later. So if you look at the area, this is a Pleiade image of our study area, which is located here to the south of Merida, Campeche, this area. You see nothing in the Pleiade image. It's a very high resolution optical image. If you look at it, you don't see much. You see a modern city, but actually here there is many Maya remains. If you look at the image, even if you make a stereoscopic visualization, nothing can be seen, which is not surprising because the area is covered by this kind of thick forest. I wouldn't call it jungle, but it's well, a kind of tropical vegetation. And if you want to go there, often in the less well-known sites, well-known to tourists, of course, and not touristically exploited, then you have to use some techniques to remove often the vegetation. So in comes LiDAR data. I think I don't have to introduce what LiDAR data is to you, but in any case, you can put it in a plane or a drone. In this case, it was LiDAR data used in a plane. It's a laser scanner which emits a lot of pulses, millions of pulses per second. Laser pulses, or it can be visible light, infrared light, it depends. And the pulses, they, in an ideal case, they hit the ground. They go back to the sensor, and we use the time it takes for light to travel and come back to measure the distance and generate point clouds. So dense point clouds of X, Y, Z data, which can then be used to derive a digital terrain model, a digital surface model, canopy height models, and so on. And that's precisely the reason why people interested in carbon storage in forests use this type of data. The story is a bit different if you fly over vegetation, because the signal doesn't always penetrate to the ground. Sometimes it bounces off on some leaves. Part of the energy is returned, and so we have actually one signal gives multiple returns. But what we are interested in, of course, in this case, is a signal that reaches the ground, but because this also reflects on the buildings and the structures and allows you to visualize them. So the data we used, actually, indeed, it's true that LiDAR data is more expensive. If you have a specific acquisition for it, you have to have project money for it. And it's easier to have large covering satellite images because they are free. But LiDAR data sometimes is also available for free because it's from previous campaigns. You can reuse it or get it for free. And for our study area, we had several LiDAR data sets covering it, in fact. One is really open. It's on open topography. It's a small study area shown here in brown. It's the G-LIGHT data, a campaign from 2013 from NASA. You can download it for free. You can also download the digital surface model for free. There is also the green one, which is from Alianza Red Plus, which is a forest monitoring project. It's not directly available for free for downloading, but if you write an email to the kind people of the Woodwell Climate Center who own it, they will give you access to cloud buckets where you can use it. It's not only available for our area, but for many other parts of Yucatan as well, and other regions of Mexico, Guatemala, and so on. And then there is many more LiDAR data also. There is a more recent project we found that acquired some data, also funded by NASA. I wrote the person responsible a very nice email asking for the data, which the response was not so nice for some reason. Mario knows more about it. In any case, there is plenty of LiDAR data available, and we use this Alianza Red Plus data, which has approximately 8 pulses per square meter, which is sufficient to derive a digital surface model, I'd say, at 50 centimeters resolution. So this is a typical workflow. We did not invent it. It's well published. Several people have done it before. What we tried, in fact, was applying deep learning algorithms to automatically detect the structures. So in short, it goes like this. You have this LiDAR point cloud, the XYZ data that comes from the LiDAR scanner. You pre-process it, filtering out the points that actually are on the ground, filtering out everything that falls on vegetation, several techniques for that. I won't go into detail. And then you can generate this DSM at about 50 centimeter resolution by interpolating it. The DSM itself, if you look at it, it's nice, but it doesn't really show much interesting things. But then what you typically apply then is terrain visualizations, like hill shading, sky view factors. There is many of them available in open source software you can play around with. And this really shows you the structures rather well. So then it boils down to playing around with some visualization techniques, or looking to literature to find ones that are suitable for archaeological purposes. And in this case, we used this one. And then already you see the structures appear very well, which means you can also use deep learning approaches, object detection, to identify them automatically, which is done with this algorithm, MASC-RCNN, which is a segmentation object detection algorithm. You can derive training samples and then run it to unseen or areas where you don't have training data, and hopefully it gives you some good results. So, well, this briefly tells a bit more about the multi-scale topographic position visualization technique we use. It was published in this paper by this person, Guillaume, and others. What it simply does is you have this digital terrain model you start with, derived from the LiDAR point cloud. It applies some filters on it in different scales, like let's say 3x3, 9x9, or you can choose it. Mostly they use 3 scales: micro scale, small filters, mesoscale, macro scale. For every moving window that goes on your digital surface model, or digital terrain model rather, you calculate the average elevation. You subtract it from the elevation of the focal pixel, divided by the standard deviation, and then you get for every scale this kind of visualization, which you then combine RGB into this, this product, combining it also with other visualizations technique if you want, blending it and so on. And this gives you things. This is hill shade, these are other ones, but we used, as I said, that one. If you do it for the entire area, we divided the study area in 4 different quadrants. From this scale, you only see the karst hills in the terrain, but if you zoom in a bit, it shows you more detail, which allows you to define some training and validation areas by visual interpretation, because this is one of the drawbacks. It's not really, if you're not an archaeologist, if you don't know the area very well, it can be challenging to identify the structures. Also because there are both buildings, but also platforms, And the platforms they used to contain wooden buildings, which of course have long disappeared. So distinguishing the platforms from the buildings and so on is not that easy, but nevertheless, you can get some idea. So identifying some training and validation data. We did have a small budget available to visit one specific site in Kiyuik. And there we had permission to go there from the local heritage authorities, which allowed us to do a bit of referencing, taking pictures, relating the pictures to some visualizations on the LiDAR data. But it's only a very limited site and certainly not enough training data to train a deep learning model and to do validation and so on. So this is, if we have more budget, this would be a bit easier, I think. In terms of the deep learning models, for students it's easy if you have a master student to just use ArcGIS instead of using PyTorch and program everything for yourself. These days it's very accessible. We applied an object detection, faster RCNN. Basically you feed an image into a backbone consisting of different convolutional layers. This gives you feature maps. On the feature map you apply an object proposal network, so a region proposal network, which then gives you some generic ideas of where an object could be by rough bounding boxes. Actually use anchor boxes of different sizes and shape that move over this region proposal feature layers. You feed it to a region of interest pooling layer, extracting all the regions, reducing them in size, and then feeding them into a classification and regression head to get confidences for the objects, how confident is a neural network that it actually detects something, and also a regression part to refine the bounding boxes, and then doing a segmentation. A lot of things, but in the end, you can do some automatic segmentation of all these objects. On a site here in Kiyuik, where the students did the training and validation, generally it appears, if you look at it visually, rather well. We do some numerical analysis and then it shows you that it's not so wonderful, but still it works to a certain extent. Although we miss, so the black lines here is around the object is something that was detected by the algorithm. And if there is these lines inside, it means it's a training area, so one that was visually sampled. So many of them are actually detected more or less correctly, although we have false detections as well, especially near the karst hills, and we missed other objects as well. So it's easier to look at it maybe another site, Huntichmul, where we have training data. But it's better to look at it from a numerical point of view. I think it makes it easier to put it in numbers. So in short, 6 is the buildings, 1 is a circle objects. We have this typical measures you use, precision and recall. Precision means if it detects all the detections the network did, how much percentage of which fraction is actually correct. And recall means if I have to detect 100 and I find 40, then my recall is 0.4. So in this case, we see that the network is rather conservative in detecting the circular objects. Precision is high, but we miss a lot of them. And for the buildings, we find many of them, but too many of them, so we have some false detections. We can improve it with post-processing approaches, doing some filtering out small objects near bigger objects, also improving double detections, with non-maximum suppression, some other techniques, and then we can improve the number or reduce the number of false positives. So in short, it works, but it's not perfect for mapping purposes, but maybe enough for detection purposes. And because we have many LiDAR data available, our idea was let's run some processing flow on all the LiDAR data that are available, not only from that are publicly available, we can ask for them. Now there is the Maya train project, if you heard about it. They are making a train line across the area for tourists. It's a megalomaniac project. but they clear jungle, they just go through all the remains if there are any. So there is also LiDAR data acquisitions. If you would be able to get them from the private companies, you could use a kind of workflow processing on the LiDAR data and to find or at least identify areas where there are some structures relatively accurately, even though you cannot map them necessarily individually. Our big drawback is we don't have archaeologists doing the field work, making the reference maps. We have some field work, but not enough. So we need more training data, and we need to also look into the algorithms, maybe use data augmentation approaches to increase our number of samples, and so on. So it's just an ongoing work. I hope to find some other interested master students, or maybe project funding to start a PhD, someone to start a PhD on it. So, but nevertheless, I want to share this with you. I have this final, visualization, but I don't think we have time for it anymore. It was a movie, but that's it. If there are any questions, I would be happy to answer them either now or just
I would suggest that we go for the coffee break now,
Okay,
and all the
yeah.
questions can
Good.
already be addressed now. So thank you for the
Perfect.
presentation. So now the coffee break will be given in the room next door, and we reconvene at 11:50 sharp. Thank you.
And finally, it's quite a good group, I would say, no? Because I was counting, we have like 50 people, which is good. Okay. So the next presentation, the first after coffee, insert techniques in multi-data assessment approach by monitoring cultural heritage threatened by natural and anthropogenic hazards. Daniel, please, you have the floor.
Thank you so much. Good morning to everybody. It's a pleasure to be here today. So, first of all, let me introduce the next. Okay, so this is the summary of what we are talking about during my speech. So just a some word about my institute, so who we are and what we do. Then we move to one of the most important threats dealing with cultural heritage at the moment. This is the climate and natural hazard, especially in Italy situation. Then I will show you some activities that we are dealing during the last 2 years, more or less. And I will finish by small windows to activities that we developed in the framework of Copernicus user uptake action. So this is my institute, just not to confuse with the ISPRA JRC, because we are another institute, okay? We have to be very clear, because we are the national agency for the we are an Italian Institute for Environmental Protection and Research, so we are the technical body of the Environmental Ministry. Our headquarters is in Rome, okay? And our main activities are dealing with, we are the national agency for the monitoring natural and anthropogenic pressure of all the environmental metrics, so we are talking about air, water, soil, and so on. We are also the technical governmental body, support the environmental industry, cultural and foreign affairs ministry. So we are a technical body to support our governmental institution. We are also the national focal point of the Copernicus User Forum in Italy. We support as well the national civil protection during emergency and crisis phases. And we embedded in our institute the Department of National Geological Survey. So I work in the National Geological Survey. I'm an engineer, but this is not a problem. But I work in the Geological Survey of Italy. And we also work, just promoted guideline, regulation, technical standard, plan for the environmental issue, and so on. So this is ISPRA Institute. I want to, as I told you before, I want to just underline something about the climate change and the climate change in the Mediterranean area and in Italy. No? Now we are, it's quite clear in our mind that during the last year, we always listen this, no? This is the hottest and warmest summer during the last 80 years in 22. Then in the summer 23, this is the hottest summer. And so there are several years that we are in the hottest summer, no? So we have to just to keep clear in mind that we are not in anomalies, but we are in a very specific trend. And this is have a clear impact on cultural heritage, okay? So dealing with this, we have to know that Italy and Mediterranean area is a very hot spot for future dealing with these, let me say, climate parameters in terms of temperature, let me say, drought, flood, heavy rainfall. So as a general matter, we know that we have every year less water, but in concentrated heavy rainfall event. So this is not, there are some of these situations, the return time, it's 100 years, 200 years. We have to be very clear that this is not extraordinary anomaly, this is a trend. So we have to be very aware about this, and we have to start to think about this is the actual scenario that we're dealing for, okay? Also especially for the cultural heritage. But what is the main effect of this situation in terms of temperature, heavy rainfall, or sea level rise? You can see here some example of, for example, of thermal stress. Here there are some places that we have the lucky to work during the last 10 years, no? So we have thermal stress that induce erosion and geomorphological instability in sub-Rupestrian heritage and so on. You can see some rock facade collapse in Petra, in Caucasus. You can see in Bolivia, this is a Acapana pyramid. Now we have problem in erosion. We have, the most famous Venice problem dealing with the sea level rise, as well as the control of vegetation in some place, or the stability of coastal erosion and so on. So all these effects are threatening the natural and cultural heritage, especially in Italy, but in Europe at worldwide level as well. This is the Italy situation, because in Italy we have one of the biggest distribution of natural and cultural heritage. Now we are the top list of UNESCO cultural heritage site. But we are also a database in Italy in which we collect more than 2,100 cultural heritage widespread in all Italy. This name is Carta del Rischio, so you can find in the website. But we also have 21 man and biosphere reserve. We have 12 geoparks. So in Italy, we have all these things. So we are, let me say, a very fragile and exposed settings about this. At the same time, in Italy, we have also different hazards. So we have a very big exposure and a very big hazard, because we are dealing with the landslide, we have a flood hazard, you have seismic, you have coastal hazard. This is all the parameter and indicator that our institute produce every year, in order to give some information at national level. So we combine the exposure and fragility with the hazard in order to have a preliminary, let me say, risk scenario at national level. You can see the density of distribution of landslide at municipal level, as well as hydraulic flood hazard or seismic hazard. You can see also, we have also the active volcanoes in Europe that are all in Italy, no? So, but, you know, just going down in the speech of today, this is the problem, okay? We have a big distribution of cultural heritage and natural heritage. We have a lot of problem dealing with natural hazard in Italy, but how the Earth observation and satellite service data and product can support us to monitoring and to protect and conserve, to make advanced policies about this problem, this challenge. You can see just some example of the use of optical images now with multispectral and hyperspectral analysis dealing with volcanic cloud, the sea level rise, the temperature anomalies, as well as the pollution, vegetation. You can see land use, change detection, and buried site. In this morning we have a lot of example of the use of these optical images that we can use. As well as with the radar images. I will show you a lot of small examples that we did in the last 2 years that we use the radar image. No? You can see some of example about this. So, you know, there is some bad news, but there is also some good news. We have new instruments, new tools in order to take monitoring about the cultural and natural heritage situation. So I want to, at first, give you some summary about a very big project that we have in Italy. The name is the National Extraordinary Plan for Monitoring and Conservation of Cultural Heritage. This is, it's a protocol of Ministry of Culture and also ISPRE, and they give to us, jointly with the University of Florence, the activity of satellite monitoring in different places in Italy, and also to calibrate and validate how these data can be used in a very correct way. No? So we decide different places with different hazard and different typology of heritage. I will give you some small example about this. So we start more or less at the beginning of 2023. So we have a different archaeological, heritage, and architectural sites at the same time affected and treated by different hazards. You can see here, this is the Parco Archeologico del Classa Harbor, Porto di Classa in Ravenna. They have problem about subsidence, large scale, regional scale subsidence. We have the Archaeological Park of Campi Flegrei. It's a very important place with different treat and hazard. Then we move to the Historical Center of Volterra. We also have our survey and calibration in Archaeological Park of Morgantina and Villa del Casale. In the 2024, we have a survey in Archaeological Park of Paestum, and also in Historical Center in the central Italy. We have Borgo di Civita di Bagnoregio, we have Orvieto Historical Center, and Comune di Pienza Historical Center. So what we do in each of these sites, we make a standard methodological approach divided more or less in 4 steps. So we start with the background, desk and field study. So we collect all the information. We work with the Sovrintendenza, with the archaeological staff, with the conservator, restorator. And so we start with all the information coming from the desk study. Then we move to a static geohazard assessment. So what the problem of geohazard in this field? We process radar imaging using interferometry technology and approach. And then we field survey in order to calibrate and verify these potential ground motion anomalies, just to make some advice if it's necessary to implement in situ monitoring. So to make a link and a connection between the Earth observation satellite monitoring and the in situ very detailed monitoring, okay? So in all the different sites. I will give you some short, because we don't have time to talk of every site, but you can see, for example, in Ravenna, we work with, of course, both with Sentinel and Copernicus data from Sentinel, as well as for, we use the Contribution mission with high resolution image. For example, in Italy, we have the Cosmos SkyMed from our space agency. So we both use this kind of data. And you can see here some of example in which the processing in Ravenna is very good. We define, for example, a big, let me say, mall in the city that was affected by subsidence, but specific in the archaeological area, we don't have particular trend anomaly. So we can just suggest to the superintendents that they only have to perform again every 1 year or 2 years this analysis in order to take to account some potential anomalies. In Campi Flegrei, for example, we have a different spot linked to fracture in the Terma di Baie. We are at the border of the caldera of Campi Flegrei. At the moment, the Campi Flegrei have an uplift of about 70 centimeters during the last 10 years, more or less. There is a lot of monitoring in this area because, you know, there is an active volcano behind the caldera of Campi Flegrei. So we suggest to implement in situ monitoring with in situ normal technician like, let me say, the crack gauge or, you know, other different in situ MEMS application. So we collaborate at local scale with this park. The same work with development as well in both in Piazza Armerina and in Volterra. In Piazza Armerina, we are able to define a very 2 or 3 spots in which there are the formation that affect, for example, the entrance of the park. So we suggest to take under control this portion, as well as in Volterra. So we, the main message about this experience that starting with the satellite processing data, also at low resolution, high resolution, it's important to go direct in the field with a very skilled person, let me say, that are dealing with the interaction among structure and ground motion to define if there are some additional monitoring at local scale that you have to implement, of course. Here you can see the Orvieto as well, or Civita. The next week we go again in Civita di Bagnoregio in order to define, because there is a small problem with there is only one pedestrian bridge that connect the Civita plateau, and this is, let me say, an important asset to maintain and to give the opportunity to visit the center. So there are some strange trend anomalies in this pedestrian bridge. So we are give our support to the municipality in order to decide how to implement a mitigation measure or to implement monitoring activity. 1 minute, let's go start. So the same approach in Paestum or in Pienza. In Pienza, it's historical. The Basilica and Duomo di Pienza is affected since a long time. So it's perfect because it's very, very slow motion during the last 5 centuries, but they don't understand or they don't learn the lessons, because at the moment there are some implementation in some part of the historical center that not take into account this problem. Let me move. We work in the Colosseo and Archaeological Park of Colosseo. We work in the Mura Aureliane during the last year, but also in Pompeii. Outside Italy, we apply this also in Petra in order to define some specific portion. We have all these things start, let me say, in 2015, 2016. We work 2015 like till now are 5 years, 6 years, but with this data, service and product means 20 years more or less. So in the 2015 we don't have any, for example, we don't have the European Ground Motion Service, so we can reproduce the analysis for all the UNESCO sites in Europe with the European Ground Motion Services. Just finish going to the activity that we developed with the European, with the Copernicus framework partnership agreement. There are some actions. So we start with GeoHazard monitoring with the ground motion. We implement a summer school in Italy last year So Patricia was one of the special guests of the school. And now we are a technical group on cultural heritage dealing with the problem of the use of Earth observation data in the community of cultural heritage. It's not an easy task to implement and perform. And now we are working, for example, also to promote the use of this data also in countries like America Latina. The next December, our team go in Peru to implement analysis in Machu Picchu and updated data in Machu Picchu and to give some training about this. You can see here some of the activities. This is last year in Chile, we work also with the use of Sentinel, but to always go in the place and to calibrate the data, to understand if it really affects the sites and the reason of. So this is we finish. Let me say that natural and cultural heritage as a strategic asset must have management and adaptation plan that aim to increase the resilience and decrease the vulnerability to the impacts of geohazard triggered by climate change by using Earth observation data and product and services. You can see this is a very not easy task because we have to collaborate with the people that comes from Earth science community, from the people that comes from Earth observation, ICT technology, from climatic science and natural and cultural heritage domain. So only combining all this information and working together, we can able to find the best solution in order to reduce the risk and to make sustainable mitigation and adaptation policy. So thank you so much. Stay tuned, and we have some update in the next month, okay? Thank you so much.
Thank you, Daniele. So I think we should move to the next presentation because before lunch we have a short question and answer section. So yes, we move to the following presentation, The Fucino, History of a Drainage Seen from Space by Tiziana Ercole.
Good morning, everyone, and thank you for coming. My presentation today aims to share with you the foundation of my research project, which concerns the early Roman drainage attempts of Lake Fucino and the resultant land reclamation schemes. The Lake Fucino in Abruzzo was set in a karstic region, and it was a basin with no outlet rivers except for some sinkholes, natural cavities draining water through the rock. Due to the frequent level fluctuations and floods, several drainage attempts were made starting the Roman era. The most impressive effort dates back to the 1st and 2nd centuries AD, under emperors Claudius and Hadrian. A long tunnel was excavated through the mountains to divert the lake's water into a river outside the Fucino area. The lake was eventually fully drained in the 19th century. The archaeological activities have been supported by remote sensing data, allowing the identification of ancient buildings, but also of important elements of the landscape, such as a crossroad belonging to a Roman centuriation, the regular model used to divide the land, some canals, and even an early cadastral system of land plots inside the bed of the lake. And let's focus on this regular set of fossilized traces because they tell us a story about a minor drainage operation and the land distribution in the 2nd century AD. When I fully consider the detected traces together with the drainage, reclamation, land assignments, and dates, the issues raised further questions which I have outlined in this slide. So what is the correlation between plots, canals, and the Roman age and the land reclamation of the 2nd century? What was the approach of local people, the Marsi, 4th to 1st century BC, to mitigate floods? And what do the sources tell us about all of it? My investigation has been constructed around 6 research areas listed here, and all my data have been processed by GIS. I must say that the contribution of remote sensing has been crucial to the understanding of some important topographical and chronological issues. However, this slide takes into account the natural drainage coming from sinkholes, as well as the early man-made draining project of Emperors Claudius, Trajan, and Hadrian, spanning 1st to 2nd century. And we see how drainage leads quickly to reclaim the land and its former Roman division in the same century. So the points list indicate important early evidence of key features of which I have highlighted in yellow. So we have to keep in mind the yellow words: natural sinkholes, pre-Roman canal, the restoration of Hadrian apparatus, new canals, renormation. After interpreting the images, analyzing and classifying all the detected features, I have identified two sets of plots, named Survey 1 and Survey 2, in strict connection with the two main canals A and B, already known by the geologists, who have dated them after Hadrian's era. Although presenting some slight differences in orientation and in plot size, both the surveys seem to belong to a same huge project of land division, probably later than Hadrian drainage attempt. More is revealed here, when there is also a match between satellite imagery and early source material from the Book of Colonies. In fact, the most amazing result of my research is to have found that the west to east axis of the Survey 2 present a distance of 1250 feet mentioned in that book. So we could say that the Survey 2 dates back to 149 AD. And this dating, what happens? Okay. And this dating is a point of intrigue in my line of inquiry. And why is this? Well, because the dating of the Land Survey 2 also corresponds approximately to the dating of a boundary market known as the Born de Rosa. We can identify its location more clearly here. And this is the Born with the inscription. The Born marked the boundaries of two Roman cities, Alba Fucens and Marruvium, as well as the sanctuary of Angitia, who was a deity and a figurehead of a mercy cult. We can see how close the Born location is to the sanctuary of Angitia here. At this point, you may be thinking, okay, but who exactly was Angitia, and what she got to do with it all? Well, here she is, the main goddess of a mercy federation. Angitia was associated with the divination, healing, urban remedies, and her power over snakes. But the extent of her overall power is now supported by a new interpretation of ancient texts. Particularly relevant to my inquiry is the mastery over water and floods, although her influence over natural events also extends to earthquakes and landslides. And we even have evidence of her influence outside the Fucino region, where we discover yet another sanctuary in Angitia's honor. And the sanctuary is located in an area that once was very wet and close to a canal system. I want to return now briefly to the Born de Rosa, which bears the clear inscription of Angitia names. Here you can read Angiti and here the name of the two Roman cities. The Born forms a crucial thread in my line of inquiry. It raises the question, why was land assigned to Angitia sanctuary according to the Born dated 2nd century AD when, at that time, the cult of Angizia had already declined. Why? Could be because, and there are various possible answers, but Angizia's control of the waters seems to be a common denominator. My particular thinking is that the pre-Roman canal, the seismic faults, and the canals had all been under Angizia's protection. The land assigned to her in the 2nd century AD would seem to reflect a belated and elevated recognition of her status. And this status may also be bound up with the governing of her sanctuary from a practical point of view. It seems possible that the sanctuary embraced some responsibility for maintaining a protected area and ensuring, for example, the upkeep of local sinkholes and so on, still into the 2nd century AD. So we come back to the title and to the final results. After the Hadrian reclamation, a first land division was carried out. The Hadrian system was inadequate, and so some new canals, such as A, B, were then digged. A new limited land division survey too was carried out, repeating the measure of 1250 feet. According to the Born de Rosa, the new drain lands were assigned to the Roman city, to 2 Roman cities, but also to the sanctuary of Angizia, an ancient local institution probably still in charge of upkeeping the main elements of the complex drainage system. And now my conclusions. The human occupation of a territory marks the landscape. The Fucinon Plate today is being constantly modified because of the agricultural practices, erasing the barrier layers of the previous age. The Roman drainage changed dramatically the Fucino region. However, the traces of this project over time have become indetectable to the naked eye. Remote sensing has unveiled this invisible heritage and has allowed the archaeologists to reassemble the puzzle of its history, hidden behind canals, stones, texts, and even divinities. Thank you.
We pass the questions for the session after, before lunch. Yep. The next presentation will be a remote presentation and is archaeological prospections in Rome using SAR technology. Diodato Tapete is going to present.
I hope you can hear me well and see the slides. So I'm pleased to deliver this second talk with regard to satellite SAR imagery in Rome. It's a pleasure to present this event because the activity I'm going to show was undertaken as part of a project funded by the European Space Agency under the Dragon Cooperation, and in particular, the 5th program, Dragon 5, lasting between 2020 and 2024. This is a huge bilateral cooperation between the European science community and the Chinese science community under the auspices of the European Space Agency. So the project was SAR archaeology. It has been completed this year. It was about exploiting satellite SAR data for archaeological prospection and heritage site protection. The program and thus the project was not only about delivering scientific research on the use of this data, but also to train young scientists in the use of this data. So you see in the list that we had several young scientists from both the European and the Chinese side. This is a program aiming to capacity building as well. And I'm sorry. And I'm very pleased to have seen a presentation in the first session, which was about the use of Sentinel-1 data. So importance of using this data means also that we need to train on how to use them properly. So the project goals included delivering new methods or advanced methods compared to the state of the art with regard to both detecting buried and subsurface features and also monitoring the structural stability of standing monuments and buildings within SAR techniques. And also we had the opportunity to make activities with different data sets from the European and Chinese side with case studies basically spread across both the geographic sides of the cooperation in China, Italy, Turkey, and Mongolia. We achieved several results, but today I show you what has been done over the province of Rome, and in particular with regard to two main activities: INSAR-based detection of subsidence threats and detectability of buried archaeological features in SAR imagery. So, as I showed also by the ISPRA colleague, Rome is an ideal place to test and implement INSAR techniques. We know that the city itself has been subject to subsidence in the past. The city center is pretty stable nowadays. But there are, of course, ongoing motions in the peripheries and in the areas that are currently being built as part of the modern urbanization of the city. We used in particular another facility made available by the European Space Agency, which is the Geohazard Exploitation Platform, and in particular among the various services, we use the one developed by the National Research Council of Italy, IRIA Institute, which is a fully developed chain to process with a smaller small baseline subset INSAR processing in a parallelized version, Sentinel-1 data. And in particular, in this project, we exploited not only these consolidated processing routine, but also the data storage and cloud computing facilities of the platform. And we processed more than 500 Sentinel-1 data in both polarization. This is a key point because usually data are processed using only the vertical polarization, and there's no enough research on the use of the cross-pol Sentinel-1 data. So here I show you some of the results across the whole province of Rome. We, of course, detected the very well-known patterns of land subsidence in the southern part of Rome, especially in the quarters that have been developed over the 19th and 20th centuries. We see pretty distinctively these arc-shaped pattern of land subsidence, which resemble, of course, the pattern of an ancient meander of the local hydrology and tributaries of the Tiber River. As I told you earlier in this presentation, we are interested also in the land subsidence in the outskirts and new areas of development of the province of Rome. So it's very well known from a geological point of view, the motions that you see here along the runway of the Fiumicino Airport. But interestingly, there's also a wider area which is well known for commercial and tertiary activities, including the Rome Fair area, where originally we had the road leading to ancient Ostia from Rome. So basically, where you see nowadays the modern motorway, there was in the past one of the major roads leading from Rome to the countryside, and in particular to the harbor of the city that was developed during the Imperial Age. So there's an area of archaeological potential. I mentioned that in this project, we focused on some experiments. Here you see the comparison of the SBAS results achieved using both the polarizations provided by Sentinel-1. On the left, the vertical, and on the right, the vertical horizontal. As expected, we collected more stable targets with associated deformation measurements with the VV channel, because we know that it's a more powerful signal being collected in these vertical polarization, but we were surprised to find quite good signal also in the vertical horizontal channel, although with less number of targets. And of course, some empty areas you see pretty distinctively here in the area of the Fiumicino Airport, an area of higher temporal decorrelation and loss of coherence. But interestingly, the patterns of lens subsidence in that area with the huge archaeological potential is visible in both the deep sets. Moving towards this area, so the area of ancient Ostia and Portus, just to recall, basically the ancient port of Rome was the city of Ostia that was located here, and later during the Roman Empire period, another harbor, the Portus Harbor, was developed with this hexagonal shape, which is pretty visible also from airplane and space. In this area, we undertook a very detailed survey of all the paleocanals, canals, structures, roads, monuments that are still buried, not only compiling based on what was already known, but more importantly using Earth observation data, accessed through the Dragon cooperation. So for example, WorldView 3, Deimos, and also other data sets through the ESA third-party mission, including SkySat. And we achieved detailed mapping with more than 1,600 map features. The project was an opportunity to compose a time series made of multi-frequency SAR data from the L band provided historically by ELOS-1 pulsar data up to X band with Cosmos SkyMed in spotlight mode. In my first presentation today, I showed you the 3-meter spatial resolution thread map data from Cosmos SkyMed. In this case, I show you the data collected at 1-meter spatial resolution. So we, of course, observed and improved the capability to detect the bird features. Surprisingly, given that the literature tells us that the X band should less penetrate compared to the L band and the C band, actually we were able to identify several features in Cosmos SkyMed data at 1-meter spatial resolution. Using the time series, here you see an example of the Northern Canal, northeastern of the Portus Harbor, hexagonal shape, and you see here pretty distinctively in the amplitude signal. There was in the past some activity made by some colleagues working at ESA, but that was based on coherence. Here you see that with the amplitude information, counting for the vegetation coverage, that in this case was not particularly an element of interference, we were able to see these traces. We coupled, of course, this assessment using Sentinel-2 data, because we know already the Sentinel-2, although a 10-meter spatial resolution, is still at a very limit to identify these buried features on the other side, given the very high revisit time, 5 days, that we can achieve also with Cosmos SkyMed data, we were able to monitor the NDVI variation and identify periods of the year where the crop marks related to the buried features are very detectable. So together, SAR and optical data can show these features and also identify periods where it's convenient to go with a drone or airborne survey data. Just to conclude my presentation, because one of the scopes of this project falling within the wider scope of the Dragon Cooperation was to improve also the existing state of the art. We published several papers in open access mode to allow a wider scientific community, including young scientists from other countries beyond Europe, to access these data, these results, and also the full methodologies to replicate. The paper that shows basically the results that I've shown today is this one, which was also recalled by the broadcast media for this purpose, because it was a way to cooperate between Europe and China to strengthen our mutual understanding of these techniques and how to use this data fruitfully for the conservation of cultural heritage and to train new young scientists. And here you see also a list of review papers, because we wanted to contrast our advanced methods with respect to the current literatures, which is quite abundant, I would say, in the use of SAR data for archaeology. So to be very honest, it's not entirely true when someone says that SAR data are not used for archaeology. It's just a matter of making this data and the techniques to use this data accessible and understood by a wider community. And with this, I thank you for your attention.
Thank you, Deodato, for the presentation. Again, we will have some questions in a couple of presentations, so stay with us. We move to the next one, Cultural Heritage and Remote Sensing, an Alliance for the Future, given by Manuela Ferri. Thank you.
Thank you. My name is Manuela Ferri from IGEOS. IGEOS is a NASI, Italian Space Agency Interspazio company, operating in the remote sensing applications and services. My presentation focuses on the close relationship between cultural heritage and remote sensing. We defined this relationship as an alliance for the future because we strongly believe that this relationship will become closer and closer in next years. So, for many years, IGEOS has been experiencing projects in the domain of cultural heritage, maintenance, conservation, and valorization. And both in the framework of European research programs, then under commercial contracts. In the next slides, I'll try to give you a quick look on the most important of our projects. I'll start with the European significant experience consisting in our participation to the consortium in charge with the realization of Heracles. Heracles is an acronym for Heritage Resilience Against Climatic Events on Site, a project ended on 2019 and realized by a wide European consortium under the coordination of Italian CNR. The applicability in the framework was the European Project H 2020. The main scope of the project was to check the applicability of forecasting models and advanced remote sensing methodologies and techniques to the identified sites of the projects. to prevent damages coming from instability of the ground, climate and microclimate changes, and anthropogenic pressure. The areas of interest of the project were selected in Italy and in Greece, and in particular we focused over the Palazzo dei Consoli in Gubbio, in Italy, and 2 sites in Greece, in Heraklion, the Knossos Palace, and the Venetian Fortress. So, as to the stability, we used to monitor the stability the IFSAR methodology, an interferometric methodology based on the use of SAR data. In this case, we used the Cosmos climate data. You see an example over the Palazzo dei Consoli on the right. We completed the analysis by the assessment of conservation status of the building by the mapping of existing cracks and injuries from on-site surveys, and by the positioning on site of a network of microclimatic and stability sensors. The monitoring period was of 18 months, all the demonstration phase of the project. So the data collection was very wide and allowed us to investigate some correlation. For instance, the main correlation that we investigated was the correlation between the behavior of the building in terms of displacement and movements and the climatic and microclimatic variations, especially in case of summer changes. This is the building energy model of the building. We made this analysis with the scientific coordination of the University of Perugia, one of the main scientific partners of the project. In the chart, you may see one of the results of this finding for correlation. The vertical bars represent the seasons, autumn, winter season for the pink bars, and for the white bars represent the spring, summer seasons. The trends of the displacement as to the results of the IFSAR analysis are on the graph, and the 2 vertical bars in blue represent 2 seasons in which seismic phenomena, seismic movements took place in the area. So, we also modeled, it's not visible in the slides, we also modeled the behavior of the Venetian Fortress, that is an artifact positioned on the shore of Heraklion to the wavelengths, to the modification of the coastline due to the action of the waves. Last, we forecasted the anthropic impact thanks to a model made available by Uninova, one of the scientific partners of the project, and fed by data on the concentration on nitrogen oxide, NOx, from public inventories, national and regional inventories, modeled on the base of a detailed, very high-resolution city model realized by IGEOS on the base of aerial data. The result is on the right is the forecasting of the wet deposition of NOx ground level in the city center of Gubbio. Right after the end of the Heracles project, we started another important project in the framework of the ESA call 5G for LART. The project is called Pomerium, ended on 2022, and was realized by an Italian consortium whose components was the University of Rome Sapienza, CISTEC department, and some industrial companies. We led, as IGEOS, we led the project. The areas of interest were the Colosseum, the Cestia Pyramid, the Terme of Caracalla, the Aurelian Walls, and the Tiber. And the investigated scenarios were related to the stability of the ground, the action of air pollution over the artifacts, and with the vegetation. The investigation on stability conditions was performed through the application of the IFSAR methodology to Cosmos climate data. You may see some results on the Caracalla, the Aurelian walls, and in 3D visualization over the Colosseum. We also realized some 3D very high resolution models from aerial data in order to visualize the vertical component of the results of the interferometric analysis. The stability monitoring was completed by the positioning on site of some IoT displacement sensors who collected data that were then analyzed by the university, by the CISTEC department, and then also correlated with the results of the interferometric analysis, showing a good correlation, so furtherly validating our remote sensing analysis results. During the project, we also made the wide use of 3D city model and high-resolution three-dimensional reconstructions, as in this case. Users may use these scenarios by a dedicated application developed during the project, and they may navigate, and they may annotate, they may mark points of interest, and so on. The 3D scenarios are the suitable environment to point in evidence and to manage features that are not visible on 2D mode, for instance, walls cracks or with vegetation on the walls. So almost in the same period, we took part of another ESA 5G for LAR project called the Extension, and focused on the city center of L'Aquila. The project was dedicated to the realization of a mobile application for the enhancement of the touristic fruition in the city of L'Aquila. So we realized 9 very high-resolution 3D models of 9 former artistic and historical buildings, and then a displacement maps from SAR data for the use of for specialistic use by the municipality of L'Aquila. In this slide, you have a look of some 3D reconstructions on 4 different sites. The model sites were 9, and on the left, a lot 2 buildings model-driven reconstruction for the visualization of the vertical components of the persistent scatters as resulting from the interferometric analysis. So recently we was in charge with another project. We participated to a project managed by Leonardo as subcontractors on the archaeological park of Sibari. Sibari is a very vulnerable site, especially towards the flood risk. Flood events are very frequent in the area. So we monitored the stability of the archaeological area and surroundings with the interferometric methodology applied to Cosmos climate data. And then we also realized a post-processing product called Common Deformation Zones. It's a product derived from the results of the interferometric analysis, and it represents the polygons in which the persistent scatters have homogeneous deformation values. So is a synthetic view of the results of the interferometric analysis suitable for the use by non-expert users. As to the flood that we know to be the main risk in the area, we realized the forecasting model based on the use of an hydraulic model developed for IGEOS by the University of Rome Sapienza. This model, this AI model, was fully integrated in our web platform Aware, and the model is triggered by meteo data filtered on some threshold values, and is able to forecast flood events and to produce as output map of expected flood speed and map of expected flood depth, as you see on the right. This is the last project in this presentation, and it's an ongoing project. We started some months ago. It's a project for the Italian Ministry of Culture. Main contractor is the Archaeological Park of Colosseum, and is dedicated to the 2 years monitoring of 6 among the main Italian archaeological parks. So the Colosseum, Ancient Ostia, Ercolano, Paestum, Pompeii, and Campi Flegrei. The monitoring is, first of all, the stability monitoring. Quarterly, we perform a monitoring by using the interferometric methodology applied to SAR data, Cosmos SkyMed data, and Sentinel-1 data. With Cosmos SkyMed, we analyze smaller areas, and with Sentinel-1, we widen the analysis to the surroundings. And always quarterly, we perform a change detection monitoring in order to assess the situation of the evolution of some features on the ground, such as buildings, vegetation, and excavations, waste, and so on, or anthropic impact in general. That might be a threat for the archaeological areas. This is monitoring performed by the use of very high-resolution optical images, in this case, Pleiad. So that's all for my presentation, and ends here. Thank you for the attention. If you have some clarification, I'll be available later for the questions. And my email address is on the slide. Thank you.
The next presentation will be on the Perseo project. Here you are. So, Giulio, please.
Hello? Okay. Good morning. Thank you for the introduction and the invitation. I will speak today on behalf of the research team of the Perseo project. Next. Okay, Perseo is a project developed within the framework of Prisma Scienza, which is a research co-founded program from the Italian Space Agency. And the objective of the project is to assess the suitability of Prisma satellite hyperspectral data in the identification of archaeological sites. The project has 3 main working packages. The first one is to develop sharpening techniques to increase the spatial resolution of hyperspectral data, and then to evaluate the data on archaeological case studies. There is also side working package about the development of semi-automated methods for the detection that will be not discussed in this presentation. So we selected 4 case studies based on diverse characteristics. We wanted to account for geographical differences, environmental differences, geological and archaeological differences. What are the traces that we are looking for? We are looking for subsoil or shallow geoarchaeological features. We were looking for road network traces, sites and structures, if we were lucky enough. And we included also paleochannels because of the availability of the data worldwide. And we also selected the case studies based on ground truth accessibility in case we wanted to perform some ground truth inspection. So some specifications about Prisma satellite. It has two sensors, one hyperspectral sensor, which has a ground sample distance of 30 meters, and the spectral range from 400 to 2,500 nanometers, is divided in roughly through 239 bands with 12 nanometer spectral sampling interval. And then the hyperspectral sensor is coupled with a panchromatic camera with a spatial resolution of 5 meters, and it acquires in a single waveband from 400 to 700 nanometer. So the idea is to take advantage of both the spatial resolution of the panchromatic image and the spectral resolution of the hyperspectral sensor. So we developed a pipeline to get to the punch sharpening. Before we had to do some pre-processing. We developed everything in Python in order to make then the pipeline accessible, not using any proprietary license. The first step, read the data cube from the IZ portal and convert to GeoTIFF rasters. So we have rasters for the hyperspectral cube, which include the Venir and sphere part of the spectrum, and the panchromatic raster. We removed faulty bands, atmospheric absorption bands, and low signal-to-noise ratio bands. And then we perform co-registration, because the geocoded version of the L2T data from AZ has some deformations that can be up to 6 pixels, so there'll be 180 meters. That can be problematic when we want to perform multi-temporal observations. So the procedures that is commonly adopted by the research community is to co-register everything to a Sentinel-2 image. And to do this co-registration, we use the software Arosix, which is open and available. And we co-registered both the hyperspectral cube and the panchromatic image to a Sentinel-2 image. We implemented several punch sharpening methods. We took 2 methods from the challenge Whispers, which was about defining the best performing state-of-the-art method for punch sharpening on Prisma data from the challenge of 2022. Which is MTF and GSA, and then we implemented our version of iSure algorithm in PyTorch, and an implementation of iSure plus another denoising filter. We then perform qualitative assessment, so we defined 3 sectors, S1, 2, and 3, in the area of Aquileia in northern Italy, and where we knew that there were relevant features to be observed, so we could make some assessment. And also we perform quantitative assessment, so we measure how good were those algorithms compared to in doing the punch sharpening from a quantitative perspective using 2 protocols, Waltz protocol and full resolution evaluation. The Waltz protocol consists in downsampling both products and then upsampling again using punch sharpening, and then measuring the differences between the original image and the reconstructed image. The full resolution evaluation just measures on the punch sharpened image how good is the spatial distortion compared to the panchromatic image, and how good is the spatial distortion compared to the hyperspectral cube. And the quantitative evaluation was performed over the entire area, showing the picture. Some words about how the iSure. This is a method developed by Simoes et al. In 2015. We converted these procedures from MATLAB to PyTorch, and the basic assumption is that we consider that the panchromatic and the hyperspectral image have a linear relationship, and And the other assumption is that the fused product, which is a cube that has the spatial dimension of the panchromatic image and the spectral dimension of the hyperspectral cube, is projectable into a lower dimensional space. And to do this dimensionality reduction, HiSure use an unsupervised unmixing technique called vector component analysis. And there is a convex formulation, which is regularized by a vector total variation, which promotes sparse image gradient. And there is an algorithm to iteratively compute the minima of this formulation. On top of this algorithm, we implemented our version of the HiSure by changing the regularization using a denoiser in a plug-and-play way. This allows us to also enable to use a neural network denoiser to be plugged into the formulation. But so far, we were using this filter that comes from the state-of-the-art. This is the block matching 3D filter. So this quantitative result shows that with GSA, using the Waltz protocol on the left, got the best results. Instead, on the full resolution metrics, we got for the spatial distortion the best result with HiSure, the novel HiSure method, followed by HiSure in the spectral distortion. However, the overall quality index, we got the best result with state-of-the-art fine sharpening. So we then wanted to perform a qualitative evaluation, so we were trying to find ways to extract the relevant bands from the hyperspectral cube in order to test which part of the spectrum was relevant to detect archaeological traces. We found out that the standard procedure that we usually do to compute spectral indexes doing band math operations was not performing well on pan-sharpened image because the ratio between the bands to calculate NDVI and other indexes really increased the noise because pan-sharpening brought some noise in the images. And we were trying to analyze visually which part of the spectrum was interesting. We created two regions of interests, one for the archaeological classes and the other for the background. And we see that there is a shift in the intensity of the average of the two spectra. But with the derivative, the spectra are quite similar, so it's very hard to find the part of the spectrum in which we can see differences between the archaeological sites and its background, so pixel nearby. We used principal component analysis to try to go beyond the use of standard RGB images. We selected manually the components which were more useful to emphasize the visibility of the features. So in the first sample, we have mostly paleo channels. In the second sample, we have on the top corner the trace of Via Agna, of the Roman road Via Agna, while on the bottom image we have the trace of there is a laser, okay, an artificial ditch probably from the Roman times. And we can make some evaluation based on this. We see that the contrast between the features is more enhanced in the HiSure image and in the GSA. And the overall contrast is even slightly better using HiSure. We also tried another method to extract relevant information from the spectrum. In this case, we use this algorithm from Morales et al. Using finding starting point, selecting, testing a recursive collinearity analysis, which we were able to extract some bands which were different from each other to remove collinearity between the bands. And then we ranked those bands based on the entropy in image classification, so how much good these images were, these bands were in discerning between archaeological class and the background. This method was good because we could extract some bands from part of the spectrum we didn't use before us. On the other hand, we often select bands which were not really good from a visual point of view because of the noise. So this was another test we made on this, but we can see that our new implementation of iSure is slightly better for enhancing the visibility of the features compared to the traditional iSure. So to conclude, we successfully enhanced the visibility of the features up to a certain scale. We were not able to see small structures or any other archaeological features that were smaller than the one that I showed you before. With our PyTorch implementation, we reduced significantly the pan sharpening time compared to the MATLAB implementation, and this is very important when you have to pan sharpen large images and large territories. And we enabled a smoother integration of any denoiser, so we can try in the future neural network-based denoiser. And we have seen from these examples that the metrics that are used to evaluate how good the pan-sharpened image are not always reflect then how good those images are for archaeologists. So the good quality of the images is from the quantitative perspective and the archaeological prospection perspective is not actually the same. So we have to find another metrics to evaluate how good these images are for archaeology. We have preliminary results published on IGARD's proceedings, and I'm finished. Thank you very much.
Thank you, Giulio, for the presentation. So now we have concluded the set of presentation for this morning, and we have, I would say, 5 or 10 minutes for a discussion. So if somebody has questions, also from our remote speakers, now is the moment. Don't be shy. Yes, thanks. Wait first.
My name is Karin Doda-Kühn. I'm going to be the coordinator of an Erasmus project, which will start in December, where we will bring together the heritage community and the Earth observation community. And my question is to Daniele from ISPRA. Daniele, I would like to ask you, because you pointed out in your presentation how important it is to bring together all these areas in an interdisciplinary approach. And obviously, you have a lot of experience with that. May I ask you, how do you arrange this interdisciplinary cooperation? What are your experiences? And how do you develop this common language? Because for me, as a trained art historian, I have to admit I will need some time to recover from all this technical information I got in the morning. This is hard to understand for me, but I want to learn, and the first step to learn is what I'm asking you.
Yeah, thank you for the question, and there is not a standard answer for this question, because the problem is that you have to start to work in every kind of project or some work experience, just to not to to involve directly different actors from different disciplines. So you have to build this interdisciplinary project by project and time by time, because it's not only a binary way, but it's you have to speak with the archaeologists, and the archaeologists have to improve and speak with you in order to share the common language. So it's not so easy. We have people that come from earth science or earth observation are not the input to explain something to the archaeologists, but to to share the data, to explain. So it's not an easy task, but you have to start to work together with these people. Meeting like this, workshop like this. I remember in 2017, there was a Copernicus for Cultural Heritage meeting that started this discussion in a very strong way. So it's not finished, this discussion, and we have to implement, just for example, involving in project or in work activities, in campaign, different actors, and to share discussion, data, point of view, and so on. So there is not a standard answer. Only to involve different part of the community in this discussion. You're welcome.
I can add a little bit there. From my experience, it comes by itself. Depends on the problem that the archaeologists are putting. For example, in Uxmal, we have now the problem that they are detecting some cracks in the building. And so, is it this instability of the terrain? So we are working with students that are experts in that technology? Or is it because the stones with the climate change, they are expanding and dilating and the porosity changes and then the rain comes in? And then we're bringing the experts in that. And so it comes by itself depending on the issue you would like to solve. From my experience, remote sensing itself doesn't work. So you need to associate yourself with cartographers, geologists. Yeah.
And if I may add something else, according to my experience, I think the major issue is always the gap, the knowledge gap between different kind of experts. You have remote sensing experts, archaeologists, site managers, researchers. Not all of them speak the same language, and I think that the most important goal is to find the right communication way, because if you produce some information that can be easily understood by an expert, independently from where it comes from, you can be a remote sensing expert actually, but you are able to show with a map to these people where they have to go to the ground and take decisions. So yes, I think really the capability building and the communication are two aspects where we need to cooperate in terms of institutions and individuals as well. So, yeah, thank you. Do we have other questions or comments? Yes, please.
Hi, thank you very much. I think perhaps one of the reasons is that translatability of information all the way to archaeologists. And while archaeologists are really used to being transdisciplinary and interdisciplinary, we have always relied on our geographers to help us with our terrain questions. And that in itself I apologize to anyone if what I'm saying is completely wrong. But it's only very recently that this dialogue is becoming open. And I think because everyone is so technical, the fact that these gates are being opened and that the information flow is really going between the hardcore, very technical archaeological problems that we're facing and the very hardcore technological improvements that you're making in spatial imagery. That connection between these two different lines of experts is this is what you're doing, which is why it's amazing. But that is also what has changed, going back to your Erasmus question. And that's where we need to train the future generation, which is what you're doing precisely in that space gap.
Hello, I'm Thomas Markavicius, Ghent University, and I have a question perhaps to you, Yolanda, or maybe to Gordon Campbell, who was giving the one of the first speeches, and it was about ESA innovation grants. And I think it's a great initiative for cultural heritage. And but I was wondering if there are any maybe plans or opportunities to apply for them, not only for Earth observation, but there are many other amazing technologies which could be extremely useful for cultural heritage. So that, and this is kind of like limited to only Earth observation, but perhaps maybe if they're not, maybe they could be in the future. So, because definitely our research group has a clear interest, for example, in space environment simulation aspects. So it's, but And we would be interested in that, but
Yeah.
so thank you.
Yes, you're welcome. So a quick comment, and then I will leave the word to Michela, to my colleague Michela. So as you have seen in the first presentation given by Gordon this morning, many of the remote sensing techniques can be translated and used for other, let's say, conservation scopes and goals, as was example from the Vatican Library. So indeed, it is a very good question because there are a lot of opportunities. And for those ones, I will ask maybe Michela if she wants to comment on this. Thanks.
Yes, so thanks for your question. So this morning we have seen some of the opportunities that are available now. Gordon was mentioning the open call for proposal procurement that is always open, so there are 4 deadlines during the year to submit your proposals. It's a very simple tendering process. Also, we have a simplified template to propose your idea for EO innovation, but it's possible to submit ideas that involves Earth observation together with other technologies, but it's still, for us, our grants are to develop Earth observation, let's say, innovation, so the Earth observation component or technology needs to be there. This can be complemented also by other techniques, but this morning he was showing some example like the mobile derived technologies and analytics. For space, you were mentioning other kind of probably.
We're interested like in LEOPS, like in low Earth in this simulator, and we already collaborated with their lab at ESA.
Yeah.
We would like to continue developing technology for cultural heritage, but and that would be one of the perfect really like an application of space technology for treatment of cultural heritage objects, not only for observation or monitoring, but actually saving them from damages.
Indeed, this is a good input, but yes, so far this kind of funding are led by the ESTEC teams. Thank you. Sure, thank you.
Thank you. Any other question? Or I don't think we have some from the remote participants. So if I'm just checking. Okay, we have 2 minutes and then we have the group picture. So, okay, otherwise I think we can stop here. Mario, what do you think? And let's coordinate now in a few minutes for our group picture outside, and then we move to the canteen in a very, how to say, organized movement. Yes, don't go around, stay with us. Thank you. Hi, welcome back. So I think we can start with the next session. We concluded before lunch the monitoring session, and now we are going into the climate and awareness session. So I would welcome the first speaker, Francesca Cigna, investigating anthropogenic and climate change threats to Iraqi archaeological landscapes with satellite imagery. Please, Francesca. We are waiting for the first presentation to be displayed, please. Thank you.
Okay, yeah. Good afternoon, everybody, and thank you very much to Yolanda and Mario for chairing this session. So today I'm presenting on behalf of a large team of scientists from the National Research Council of Italy, the Italian Space Agency, Newcastle University in the UK, UNOSAT in Switzerland, and last but not least, our local champions from Iraq, from the University of Al-Qadisiyah. So the presentation is about the results of a joint project that we have started in the framework of a bilateral cooperation program between the Italian CNR and the UK Royal Society, which is focusing on imaging vanishing landscapes of Iraq under anthropogenic and climate change threats. So what we are doing is to exploit all the available satellite Earth observation data to try to improve our current understanding of the recent and future threats to the local heritage archaeological landscapes of the area. So why have we selected Iraq? Because the country has been placed in the top 5 countries of the world most affected by climate change impacts. And in particular, threats to heritage are both natural, coming from processes relating a lot and impacted by climate change, like erosion, desertification, weathering, and also dust storms, but also a number of human-related factors, such as factors connected with conflicts, but also new developments, so development of new urban settlements, but also expansion of agricultural areas and things of daily life for a community. So our area of interest, as you can see in the picture, is quite famous. We are looking at Mesopotamia, so the floodplain between the Tigris and Euphrates river, so it's the cradle of civilization. So very rich in terms of heritage, in terms of archaeology. So in particular, as you can see in the screen, I don't know how to use a pointer. Okay, I'll just use my hand. So can I touch it? Don't worry. Okay, I'll do like that. So as you can see in the figure, we are focusing in particular on a stretch called Abu Jir lineament. So it's the geographical division between the Arabian Desert and the floodplain. And along this lineament, we have hundreds of ancient springs connected to ancient canal systems, agricultural cultivation systems from a number of different periods. In addition to springs, we have a number of forts. Thank you. A number of forts, ancient settlements, but also farms and things connecting with the agriculture of the region in the past. And we see a lot of this heritage still preserved today, but impacted by a number of processes. So why climate change is important in this area? Well, because if you look at the historical records for the last century, we have already witnessed a significant increase in the average surface air temperature of the whole country. If you look here, we are talking about 21.5 at the beginning of the century, rising up to almost 24 degrees in 2022. And the same with precipitation. We have witnessed a decrease in the total annual precipitation of the country. And if we look at the next decades, what we see is an increase in the average temperature and also an increase in the number of precipitation anomalies that are projected to occur. So this all connects with the overall picture, telling us that climate change will further worsen the situation of the local heritage of the region. So what we have decided to do is to exploit Earth observation data for 3 main scientific goals. So the first one is, of course, archaeological mapping. So first we had to identify all possible archaeological assets of the region, and we've done that starting with hexagon KH-9 data, so these are declassified military photographs from the US Cold War. They were declassified only a few years ago, so they are quite new in terms of Earth observation data source. And we've complemented the mapping with a medium to very high resolution optical and SAR imagery from very well-known sources like Google Earth imagery, Landsat, but also PlanetScope. And last but not least, we've launched a Cosmos SkyMed Spotlight enhanced campaign with 1 meter resolution data over a set of priority sites. So archaeological mapping is followed by change detection, and the core of our change detection approach is based on Sentinel-1 SAR data and Sentinel-2 optical data, as I will show you in the next slides. And we've also invested in some impacted area mapping at country scale by looking at dust storms over the last 3-4 years using Sentinel-3 data. So if we start with some results from our archaeological mapping, here is a zoom of our detailed mapping and identification of canals in one of these local focus areas of the area of interest. So this is the course of the Euphrates River today, and this is like a relict path of the river that we are looking at, and all these lines are basically networks of canal systems that we can see in the historical Earth observation data from Keyhole, but some of them are also still visible today. Some others have been overlaid, some others have been totally destroyed. And as you can see from the network that we have mapped, there is an interconnection of some of these channels. We can also recognize different phases of canal constructions based on their spatial interconnections and the overlapping of the different systems and changes in time that we've identified. So this is a zoom onto a particularly interesting sector of the area. This canal in pink is an ancient Sinus canal that is recognized in the old data, but is also has been re-exploited, let me say, by more modern systems. As you can see in the original data, the canal was quite easy to identify in the old photographs, but also if you look at more recent data with Cosmos SkyMed, by zooming into this part of the network, you can clearly recognize the backscattering signature that is stitching out of the surrounding landscape in the radar data. And together with that, you can see a number of other features. Some of them are of natural origin, some others have anthropogenic influence and will be discussed later. So going into detail in our change detection approach, so let me say it was a multi-scale approach. We started from the regional scale by exploiting Sentinel-1 data. Given their particularly large image footprint on the ground, we could cover basically the whole region by using 2 different tracks. And what we've done is to create a multi-temporal set of yearly pairs, and we've used differential interferometry. In particular, we computed the interferometric coherence between pairs of images to quantify the amount of change occurred between one year and the other one. So this is a typical product. It's a parameter varying from 0 to 1, 0 indicating total decorrelation, so no coherence because there has been a change due to different causes, and 1 is perfect correlation, so basically the value of the radar backscattering was identical in image 1 and image 2. So here is our multi-temporal sequence of change maps at regional scale using Sentinel-1. As you can see, they are really similar at this scale. What you can recognize is a clear pattern of bright areas across the desert, because no particular change was recorded across the desert, except for a few changes that I will show you later by zooming in. And here is the plain of the two rivers, and as you can see, it's really dark because clearly the river plain with all the agricultural fields and activities are very dynamic. So from one year to the other one, the change is particularly significant and is clearly detected even at this scale. So these products are at 40-meter resolution, so they provide a good overview at regional scale, but they need to be integrated with something else at a more detailed level, as I will show you later. But by using these products, what we have done is to take the full set of ancient springs that we've been able to map using historical data, and for each of these springs of the Abugir lineament, we extracted statistics from the change maps, not only at the location of the spring, but also considering a buffer zone of 100 meters around each of these sites. And this was to try to understand the amount of change in the proximity of each of these sites over the last 10 years. So this is the overview, but the cumulative map, let me say, is much more interesting. So here you see the overall result across the 10 years of analysis, and each point of the spring is colored according to the average yearly coherence from 2014 up to 2023, so over the 10 years of analysis. And every time you see points with a color approaching dark blue, it means it was coherent, so there was little change across the decade. Every time you approach yellow and red, it means the change was much bigger. As you can see here, we try to recognize two different clusters. We call the northern and southern cluster just for geographical reasons. But what we can see is that from the center of the area towards the north, basically the behavior of the different springs was variable, ranging from unchanged sites towards moderately changing and decorrelating sites, whilst to the south, from Najaf Sea towards Hammer Lake and Basra, the town of Basra, and Nasiriyah, which is here, the change is much stronger. So most of the points are in this range here, so we are talking about 0.2, 0.4 coherence, so a particularly low value. And this can be explained by looking into more detail at Sentinel-2 data. So what we have done to scale down the approach of change detection from the regional scale to the more local scale is to take Sentinel-2 imagery. We've developed a simple workflow using Google Earth Engine, and we created early mosaics of Sentinel-2 scenes for the same periods that we were looking at with Sentinel-1 data. We performed some quality check and cloud filtering to make sure that the values in the pixels that we wanted to use for the following analysis was of good quality and free of any clouds. Then we computed some vegetation and water indices, and pair by pair we tried to assess the amount of change between one year and the other one. So without going too much into detail, the two key products out of this workflow are basically NDVI, so normalized difference vegetation index maps with the associated change maps. As we can see in this example here, every time you have a significant change, either towards the green or towards the red, you see something like that in our products. And we also computed the so-called change magnitude products that I'll show you later. And these account not only for the red and near-infrared bands, but also for changes in all possible bands of the spectrum. So if we look at the sequence of our results, I'll show you the NDVI sequence first. So this is the local scale area of interest. The dots are the sites, so both ancient springs and settlements, so archaeological tells, fortifications, and so on. This is a famous Sawa Lake, which made the news a couple of years ago because it totally dried up due to desertification and climate change. This is another famous landmark is Harman Lake. And this is a series of springs along the Abugir lineament. So NDVI tells you the amount and status of vegetation. The greener, the more vegetated, and closer to red, we have water bodies. If we go ahead with time, you can see the evolution of the area, and you can see the appearance and disappearance of water bodies, like Hammer Lake is not there anymore, and the appearance of a number of features in this area. They are even more apparent when you look at the NDVI change sequence in here. I'll swap through the different yearly products just to show you. As you can see, even over the last yearly analysis, what we've seen is the development of hundreds and hundreds of these new modern pumping systems and irrigation systems called Central Pivot. I'm sure you know about them. They are basically circular irrigation systems centered on top of a water well, and they spread water through a moving and rotating arm. So many of them developed in the desert, but also many of them, unfortunately, developed by impacting the ancient agricultural systems and ancient farms, so by damaging the archaeological heritage of the region. So these ones are the other products that I was mentioning before. I'll move faster because time is running out. But the most important thing is here, when we draw some statistics from the changed products, what we can do is to try to quantify the amount of unchanged and unchanged sites in our study area and try to analyze the evolution of changed and unchanged sites in time. What we see in general is that by approaching 2023, there has been a decrease in changed sites when looking at the NDVI change only. But when we look at the change magnitude products, we see actually an increase in the surface changes, possibly linking also with drop in precipitation and changes in soil moisture. Last example, a couple of slides to show you incidents of looting. So archaeological looting is unfortunately a very frequent process that we have been mapping in the area. Here, a couple of examples that you can see very clearly from Google Earth. A number of sites developing looting holes that are clearly depicted by the very high resolution Cosmos Climate data and 1 meter resolution data through the clear texture of the looting pits. And here a canal construction that happened in relatively recent times by crossing an existing archaeological tell that was later totally flattened to create space for other activities and was crossed by a number of vehicle tracks, but still some signs of the presence of the site was seen in the Cosmos Climate data. So the project is now approaching the end. We have already published a short paper in the IEEE proceedings. Another one is coming, and if you want to know more about our results, you can keep in touch or access these papers. Also, to get a flavor of the archaeological details of our study area in these papers led by our Iraqi partners. Thank you very much.
Thank you, Francesca. We have time for one quick question. If not, we move to the, oh no, we have it? No. Then we move to the next presentation. Thank you, Francesca.
Please, Alexandro Sardella. He's going to talk of new strategies to enhance the resilience against climate change for cultural and natural heritage.
Thank you very much. Good afternoon, everyone. My speech today focuses on the presentation of the activity carried out by our research group in Bologna concerning the application of Copernicus services and other Earth observation-based products, and how their integration with the climate projection from global regional climate model could constitute a notable innovation that will deliver a direct impact to the management of cultural heritage, cultural and natural heritage at risk, with, of course, high potentiality to be scalable to other new sectors under threat by climate change. So, cultural heritage at risk, we heard about this issue in this morning, and of course in the presentation before. Climate change, this is the concern driving our research in this field. Climate change and pollution are creating continuous and new challenges for the protection of cultural heritage. And monumental complex, you can see here an example of the flood in the Emilia-Romagna region in 2023. Archaeological site, monumental complex, historic center are at risk as a consequence of the impact of climate-induced extreme event, but also also pollution. Moreover, it is also expected that cultural heritage will be potentially be exposed to unknown multi-risk situation, posing new challenges for its safeguarding. So, our research group try to find the solution to this issue, participating at several European projects, international projects, and here you can see the last project, the most recent project founded by the Interreg Central Europe program, the project INACO, with a main aim to increase the resilience of heritage sites in river basin district. As you can see, 7 countries have been included, with 11 partners from different countries in Central Europe. So, this project, INACO, will capitalize and will constitute an upgrade of these 2 previous Interreg Central Europe projects, coordinated by CNR ISAC, set up in order to satisfy the need of the end user. So these 2 projects are have been devoted to specific need. As main output of these 2 projects, the risk mapping tool for cultural heritage protection was designed and implemented to support policy and decision makers in the identification of hazard-prone areas from a climate point of view, and in the vulnerability, in the assessment of vulnerability of cultural heritage exposed to climate-induced extreme event. This WebGIS tool will be also capitalized in the new project. And this is the methodology at the base underlying the risk assessment of cultural heritage exposed to climate extreme event. As you can see, on the first box on the left, the blue box, the elaboration of hazard map linked to is a key step to identify hazard-prone area from a climate point of view in Europe and Mediterranean basin, exposed to calamitous events such as heavy rain, flood, flash flood, drought periods, and heat waves. And the identification of this hazard-prone area, together with the, at regional scale, together with the vulnerability assessment at building and local scale, allow us to identify the most appropriate measure, preparedness measure, in order to increase the resilience of a different category of cultural heritage. Of course, the category considered in these 2 projects. with a focus on the first part related to the climate, the analysis of changing climate extremes can be done using indices, specific indices to evaluate statistics of extreme event for precipitation and temperature, and to compare them with observed extremes. So for this, we selected specific climate extreme indices among the 27 indices defined by the expert team of climate change detection indexes, ETCDD, for mapping historic and future variation of these indexes. After the selection of the indexes, we conduct the analysis of their variation by the elaboration of historical change by using dataset, EOPS dataset, and also exploring Earth observation dataset of climate data, mainly from Copernicus, in particular Copernicus Climate Change Services, their analysis ERA5 and ERA5 Land, and also some product from the NASA JPM IMERGE in particular. And of course, the analysis of numerical climate model simulation for the elaboration of future projection. The final result is the production of climate map in order to evaluate the hazard-prone areas in Central Europe. In the table on the right, you can see the different data set and used for the elaboration of our products. And this is an example of the two tools, two application available in the risk mapping tool for cultural heritage protection. One for the investigation of the historic variation of these indexes, and the other for the investigation of future projection, in particular in the near and far future, under two RCP scenario, 4.5, 8.5, with a resolution 12 kilometers per 12 kilometers. We use 12 different combinations of global and regional climate models. So at the end, we, in order to reduce the uncertainties due to a single model, we keep the entire ensemble and considered all members of their statistics. So calculating the mean, minimum, the mean, and the maximum of the model, and create our data set of map. Concerning the exploitation of Earth observation based data set, we focus the attention on products, as I mentioned before, products developed by Copernicus, in particular the two reanalysis ERA5 Land and ERA5, for precipitation and temperature, and also NASA JPM IMERGE for only for precipitation. You can see here, you can see two examples, one map and one time series related to, in particular, in this case, is for the Earth 20 millimeter extreme indexes as three different locations. And this is a yearly time series. Of course, not only the identification of hazard-prone areas, but the vulnerability evaluation play a key role in the for the risk assessment and reduction for the cultural heritage under threat, and it is essential for the definition of strategy for climate change adaptation. In our projects, we intend the vulnerability as a combination of three main requirements: susceptibility, exposure, and resilience. And we ranked this vulnerability in 5 classes, from low to very low. And this methodology has been set up strictly with a strict collaboration with local stakeholders at local level. The methodology has been applied in 15 different case studies, characterized by different cultural heritage categories and different impacting hazards. And on the right, you can see an example on the Parco Villa Chigi in Bologna, particularly exposed to flash flood, erosion, landslide, but also vegetation damaging. Means that heat waves, they have very ancient tree protected, and heat wave caused very, it's very important to know the future of this kind of, because there are, sensible to temperature. And this is an example of the map for 3 different climate extreme indexes from climate modeling, indexes based on precipitation variation, in particular very heavy precipitation days, or consecutive dry days, or RX5 days. All these maps represent the ensemble max of the previous model showed before in the far future under the pessimistic scenarios. This map was elaborated using the tool that I showed before. In the future, in the new project in ACO, we are adding we have new case study selected in considering 3 different environmental framework. So you can see we have cultural heritage assets in the river shore, but also in lake shore and in river, inland river, in order to upgrade, of course, also the vulnerability methodology, and take into consideration also other cultural heritage category not considered in the previous project, such as the wetlands and natural resources. Next step in this ongoing project, I mentioned the project mentioned by Daniele Spizzechino this morning, the Extraordinary National Plan for Monitoring and Conservation of Italian Cultural Heritage and the project Ecosystem, where all these field of research have been included in order to set up a vulnerability both web and mobile app, both for professional and citizen, but also for implement upgrading the processing and the exploitation of products from C3S and CAMS. We also work on underwater cultural heritage, so our intention is also to exploit also the CMEMS in this case. So the final aims of this project is to implement risk management plans based on the application of the solution found in this in ACO project in CE, Central Europe River Basin District. This is the last slide, only as an example of the application of the different products comes from eMERG, but also ERA 5 land. So we, as a research group, we work on the assessment, the impact of extreme event and pollution on material for cultural heritage. So we work also on damage function. And this is an example of damage function, surface recession, that include different parameters. So, for example, NO3 or humidity or particulate matter. And this is a map representing the surfaceization in the Mediterranean basin for 2020 and 21. So we are working also on this. Only some reference regarding this work, and thank you for your attention. The risk mapping tool is available, is free. Of course, we are waiting for some suggestion and comments. Thank you very much.
We have time for one question.
Then I have one, sorry, just a quick one.
Yes.
Concerning the area that you mentioned outside of Italy, so the other areas for wetlands and other water basins, do you have contact with the local authorities or local people using then your...
We are in contact with our partner, of course, in the project that are directly involved in the management of the cultural heritage site. So, for example, in Italy we have Parco del Delta del Po that manage directly Valle di Comacchio, for example, in the delta. So in the Lake Balaton, of course, the wetland in the environment in the lake context, we have the Lake Balaton region. So they are. We worked with them also in the previous project, so we have a strong cohesion with, of course, local stakeholder.
Yeah, they are involved in the project,
yes,
and
yes,
they will use the. Okay, thank you. Thanks.
Thank you very much.
Thank you. So we move to the next presentation given by Katia, but not only, yes. New methods and tools for preserving cultural heritage in the future apply to monitoring coastal degradation along the Tunisian shore within the framework of the CIG Africa Collaborative Mapping Project. Please.
Okay, thank you. Hello, everybody. The scientific goal of our project is to provide an accurate cartography, is to assist in determining key archaeological research targets. It is to assist in providing an initial assessment of archaeological terrain or site and monitoring them. It is to serve as an essential archive and conservation document, prevention and preemption tool. And the objective also is to determine future priorities and institutional guidelines for heritage. There is a first application of our project. Here we are in Algeria, in the south of Ores Mountain. You can see a map given by the project Africa. It's a GIS. And you have in red the antiquity cartography. All the cities are well pointed. The red line are only the indicative route of the Roman road in this region. And the aim of this project is to find the route of the Roman road between two cities. One is An Medias here, and the other one is An Majores. For that, we have many kinds of information. One is, for instance, the approximate location of the Roman milestone, of a view of one of them, given by the first researcher in the region. Another one is given by the satellite image. It is the identification of Roman cadastre in the plot of land in modern time. And we have found it in some location given by the set of rectangles, which are the modelization of Roman cadastre. And there is a link between Roman cadastre and the road, and that's why we propose the purple route for this road. And after, we will perform a terrestrial survey to confirm that. The next slide is given by Sentinel-1 radar image. It is obtained by an averaging on 40 images to reduce the speckle. And you can see a remarkable part in this image, which like a root structure that should be the water flow which occur after storms. And the radar image is sensible to the roughness of the soil, and the roughness here is given by alluvion deposit by the water flow. And you can see that the mainstream of the water flow don't reach the Roman road. That say maybe it's a good solution for the route of this Roman road. Prospection terrestrial, which confirms that, we hope. You have used here radar image in Tunisia, in the same latitude. That's the last one, with a Terrasar X radar image. Here you can see this image highlight the wadis, intermittent wadis in this region. It highlights also a Roman wall on 17 kilometers that you can see here on the image. You can see a straight line, here. If you look at an orthophotography, you can see not many things. You can see the Roman wall just a little. So this radar image is interesting to have a geographical context to revisit this region for archaeological new prospection. I'll say a few words on the Africa project. It's a collaborative mapping project of the ancient North Africa with an historical and archaeological database. You have the main Roman sites which are pointed here, the more exactly as possible with the source we have, and with the satellite image. And you have also many lines which are, like in the first study, the indicative route of the Roman road. The GIS Africa is a tool to highlight the contribution of spatial imagery to historical and archaeological research. It's an inventory of knowledge of the ancient North Africa. It allows to revisit past study and to raise new questions, thanks to the reality on the ground provided by space imagery. And we can supplement them by aerial image, of course. It contributes for study, as you have seen firstly, and to the preparation of field survey, using all the available data we have, archaeological one, made in coherence by cartography, and the contribution of public satellite image, and source from specific satellite tasking. It can produce scientific map on historical work, archaeological, geomorphological, etc., and participate to future publication, of course. And it's a synthetic communication tool for study results. The access to information through this map is also arranged by collaborative modes. There are two modes, a GIS mode with the well-known, for instance, software QGIS, and the future access through the web SIG of Laboratory Archaeology and Philology of Orient and Occident of the École Normale Supérieure in Paris. Its name is Chronocarto, and Africa will be on. Africa is also a database. For each site, for instance, you have many information. A first database, we describe at low level the site, and many secondary tables joined to the first one, we describe in detail for historical and archaeological point of view the site. And also you have cross table, which, for instance, the bibliography. Sorry. Here is a zoom on for future study that Katia present to you on the Kerkina Iceland. They are on the east coast of Tunisia. You can see an extract map of the Africa GIS project here. In the rectangle, you have the region near the Kirkenes Island. You have all the Roman sites which are pointed here, well pointed. There are many. And here is the Kirkenes Island. You have, if we know the Latin name of the site, they are written in epigraphic character, in fact in majuscule here. You can see Caput Vada, also Justinianopolis, Hakola, Ruspae, Trafura, and so on. And here Kirkenes, which is the main site, Roman site of the Kirkenes Island. It is that gave the name of this island, of this archipelago, in fact. Here is a zoom on the archipelago. And in fact, to work on, we have performed a tasking with satellite plate image of three stereoscopic acquisition in the framework of the Dynamis French project, which is made for the French laboratory to acquire image in very interesting condition. Here is the DSM we have produced with the stereoscopic images, and there is a very low mountain. Katia speaks more about this geography. Here we have a zoom on the Kirkenes Roman city. We can see a dish around, and here is the orthophotography, which show a very transparent water. And Katia, it's you.
Right, so now that you've got the entire context and seeing how we actually go from the very large to the very small, I'm going to zoom in very quickly as possible, to what we've actually done in the Kerguelen Islands, and how the imagery has actually helped us both on the site and understanding what we're going to be doing next. So here, just as a detail, the satellite imagery has actually highlighted the key feature of the ancient city, as you can see in detail. So actually it gives us details on the urban area, the enclosure, but quite interestingly and importantly, it's shown us that the urban site actually extends far beyond the actual current site boundary. So that's interesting for site management. What is important on our site is that actually there are very different types of marine transgression, and this is where climate patterns are important here, because the site is being affected by climate change, severe weather patterns, subsidence, and sea level rise. That's where the archaeologist in me actually comes out. That's been going on for a very long time. Actually, we know the site from Herodotus already. Subsidence has been going on since at least 2,400 years, so it's not a modern phenomenon, but it's been increased. We actually have quite a lot of detailed information about how that shoreline has actually moved. So here you actually have an image that shows the shoreline in antiquity, since we actually have the ancient Punic and Roman harbors that are already submerged. So we've got already a 2-meter level change since antiquity that has already buried underwater, the military, very important military Carthaginian harbor, as well as the Roman harbor. But what we wanted to do is, what's next with this site? And that's where looking at the different imagery and putting the information together, we've been monitoring the shoreline evolution and have determined mean average over the last sort of decade, between 2012 2022, and gone into detailed monitoring of how much has been eroded on very particular areas along the coastline. I'm going to be zooming through because I know that we don't have a lot of time. So ask me questions if you want. But pushing that concept of trying to understand that, yes, we all know that climate change is impacting our coastlines and it's impacting humans. We know that in Tunisia, for example, 75% of humans are living by the coastline. That's affecting them. It's also affecting our cultural heritage. If we take these data and if we project them according to what the GIEC has been asking, sort of monitoring and looking towards the future, then we can, from the data that we've analyzed, we can sort of see that in our area, the recession or the shoreline is going inland at least 10 meters or 27 meters, depending on individual area from its 2022 position. The archaeological site itself is going to be quite impacted, so at least 12-meter difference. We're going to lose 12 meters of this important site by 2032. And if sorry, I'm going to, no, I'm not going too fast, but we've been keeping on projecting that model, obviously with all the complexities that go along with it. But what we can foretell is that we're going to see the loss of between 20 and 50 meters in that area alone, with 22 meters of the archaeological heritage site that's going to be disappearing. Now that is, to us, is very important in terms of telling the institutions not only how much they're going to be losing about the sites, but also where they should be documenting more rapidly than other places, because the coastline is not eroding at the same rate. So that's important in terms of actually foreseeing where we as archaeologists need to be putting an impact and where we need to work first and what can wait in terms of what will be preserved. In terms of Carquena, we have quite a bit of archaeology that's going to be at risk, and we've been able to demonstrate that probably a third of the facade of the city along its coastal cliff is going to be eroded, and we're pushing towards and explaining that this is actually where we should be putting our archaeological priorities for the next decades or so. Now, the coastal erosion is going so fast that even simply monitoring is not the only thing that we have to do. We've been trying also to push towards georeferencing digital twins and using artificial intelligence, because actually it's eroding so fast that humans just simply can't work anymore. So that's something that we've been working towards and including in the project, is simply actually doing accurate modeling, and that's where 3D imagery and digital twins coupled with satellite imagery is really going to be pushing forward for the future, and we've already seen that at the beginning, actually. So I'm going to say simply as a conclusion that satellite imagery has, and we're all convinced of it, substantially changed how we can monitor shoreline recession, but also how we can have an impact on cultural heritage and archaeological sites. From our project, we believe that actually twinning it with georeferenced digital models, it will be a further asset, especially when the data is then included into substantial GIS databases, such as the one that we've been using, the GIS Africa, which we've developed and which is designed especially to receive that sort of contribution, which will be open and which is open to other projects. And it keeps on showing that we can have qualitative contribution from spatial imagery to practices in archaeology, so not only from preparatory field studies to ongoing monitoring, but I think also for institutions thinking about post-operation practices and where we should actually put our priorities. With that, I'd like to thank you all, and I hope we can have questions now and after. Thank you.
One quick question. Is there any question? If not, then thank you for the presentation.
We move to the next presentation, which is Copernicus Climate Data for Heritage Preservation in Malta. Fabien, thank you.
Okay, hello all. So we will talk here about Malta and how we can use Copernicus Climate in this context. First, very brief words on who we are. So I'm here on behalf of Memoration, which is a private company. We work, well, our ambition is mainly to put environment at the center of the decision-making process. And for that, we based all our work on satellite data, mainly on Copernicus data, but also on broader sources. And the economic sector that we primarily address is tourism, which can be quite unusual to talk about, well, special data for tourism, but that's all the point here. So the context here of the work we carried out, so we worked for the Malta Tourism Authority, and here, so Malta is a quite specific place. Mainly first, I would say that there is an island mentality in Malta, and by that I mean that Maltese people are used to live on limited land and resources, and from that they have a strong incentive to understand their relation to nature. That's one point. They also have a heavy dependence on the outside world, for instance, regarding Italy for food, for instance. And that means that they have to anticipate risk on the island and also on the neighborhood countries. In Malta, so tourism is a very important activity. It's basically 1/3 of the GDP in Malta. But so all this tourism activity also put a lot of pressure on natural and cultural sites. About these cultural sites, well, Malta is a very, well, culture and history is very rich in Malta. It's at the crossroad of Africa and Europe. So there is a lot of cultural sites that are a bit underexploited. So there is a wish from the Malta Tourism Authority to exploit more the cultural sites, but still trying to preserve them from the pressure that can come from tourism. There is also no problem. They also want to preserve them from the impact of climate change. We saw on the other presentation that climate change can have a lot of impact on cultural sites. So for all these factors mean that they have to innovate, and they need innovative indicators to be able to monitor all these factors. The question from that would be, how do we provide indicators that can be used in the decision-making process? And one answer to that is to include these indicators into a broader framework. And for that, we used the, well, very well-known SDGs from UN. And here the idea is to ensure that the indicators that we will provide will be consistent with the overall policy in the island. Because tourism is linked to many different environmental factors. And that's what we will see in the next slides. Here we can see different indicators that we provided to the Malta Tourism Authority and how they are linked to different SDGs. And we can see that the spectrum is actually quite broad, maybe broader than what we will think about tourism activity. Now I will dive a bit more into some specific examples of indicators we provided and some environmental angles we addressed. And first one is related to urbanization and soil artificialization. Here, one thing to know is that Malta is, well, ranks among the EU countries with the most artificialized soil, percentage of artificial areas. And so we looked at how urbanization is progressing in the island, and it's actually not very big in absolute numbers. But if we remind that, well, land is very limited in the island, so even small progress in absolute number means that there is still a lot of pressure on available lands. And here, yeah, we worked from Sentinel-2 images to classify artificial soil. We then looked at air quality in the island, and here there is one main finding here is that air quality in Malta doesn't really depend on what is happening in the island. So there are two main sources of pollution in Malta. One are particulate matters from the Sahara Desert, coming from dust plume events. And there is also another important source, which is ships coming from Gibraltar to Suez Canal. And we can see actually here in, oh, I have a pointer, right? Yes. We can see actually here, this is the road of the ships going here that are passing very close to Malta, and we have NO2 pollution in Malta due to these ships. So, well, that's a finding here, and here, Malta cannot really do anything about this pollution, but it can anticipate dust plume events from deserts, for instance, to protect the population. Another topic that we address here is about what they called in Malta Wedian or weed, which are very specific areas. Actually, they come from old riverbeds. That there is no water anymore. There is no rivers in Malta, but we have this kind of areas here. With a lot of vegetation, but also people are living there. So we have some towns here. And well, the need here is to first map these areas, because it's not, well, we had to develop a kind of a methodology to define exactly this area, map them, and then monitor how they evolved, how they are impacted by climate change, how is vegetation evolving in these areas. So it's yeah, quite interesting areas here. So yeah, as it's very, very specific, and it's a mix of cultural and natural heritage, actually, these areas. Next topic, we also provided indicators on water quality. So here, by water quality, we mean mainly turbidity and sea temperature, which are two variables that are quite related to tourism. We made a focus on some specific tourism point of interest, like, yeah, of course, beaches, which is a big part of the tourism offer in Malta. And here, well, we noticed something quite interesting. I will show that. Well, first we have a difference between east and west coast in Malta, which is due to water dynamics between Sicily and, well, it's very natural cause. We also, well, noted, for instance, here a specific area, which is this Ramla Bay. It's in Gozo, so it's a north island in Malta. Here we notice a specific turbidity effect. Well, water is very turbid in this area, and we could think as it's a high spot for tourism. There are a lot of tourists coming to this nice beach. So we could think that there is a link here, but actually here there is something interesting, and we have to look back in the history here. Actually, when when the island was ruled by the Hospital Knights, this place was a spot for pirates' attacks. And so to prevent that, the Knights in the island built a wall underwater so that ships could not enter the bay anymore. And so they put big rocks of sand, big rocks in the water, and the rocks are still there, and they are slowly disaggregating. And so that's why the water is more turbid in this area still because of that. So that's just an example of, we have observation from space here, but if we want to understand them correctly, we should also look at, well, the knowledge from the terrain and what is actually happening on the ground. Okay, so regarding water quality, there is also something related to fish farms. There are a lot of fish farms in the Maltese coast. And here the idea is to monitor what is the impact of these fish farms. So we used different indicators, with mainly NDVI and turbidity index computed from Sentinel-2, to look at the impact of this fish farm when at different distance from the farms. And we showed that, so here we have turbidity here, we have the distance, so here we are on the fish farm, and then we go further from the farm. So we show that basically at some around 50 meters from the fish farm, we don't have impact anymore, or we have very low impact, and then impact is going down on the turbidity part, and on the NDVI, which in the water will allow to monitor chlorophyll. We also have a very small impact. And so this was for the first one, and for the second farm we have here, we see the same pattern, but well, as the farm is on a closed area, on a closed bay, we also have more impact of other factors, but we see again that the impact is quite limited, and that was the information that the authority, they were quite happy to see that. Last example here. So I will talk about climate projection and how climate change will can affect this cultural heritage here. We will look at two different aspects. So air temperature, rise temperature, and sea level rise. Not going into much detail here. So we provided very simple indicators on the rise of temperature, mainly showing that, the average temperature will rise, and that we'll have also more frequent heat waves. Nothing really surprising here, but still it's very interesting for them to have quantified values about that. And so last example I will show here is related to sea level rise in the island. So we modeled sea level rise in a quite simple way on the Malta coastline. And we cross-reference this information with heritage sites to show some specific sites that could be in danger, like we see here, which is a church. And we did that on all the island to really highlight where effort should be put to preserve heritage sites. Okay, so it was a kind of an inventory of different indicators that we can provide for specific to tourism activity. But as I said, tourism is has a very large spectrum and is related to many different environmental, social, and also economic factors. Copernicus can definitely be useful in this field. I think we are all convinced here. I highlight again the need to integrate all this data into a broader operative framework if we want to have something effective. And yeah, here the idea is really to help decision making and to help planning and anticipating risks. Okay, I will be happy.
You know, we are in the European Space Agency. Everything needs to be run on schedule. We are running late. That's why, no question. We propose to make just a break. Coffee is outside, but be quick in 5 minutes because they are preparing the icebreakers. No coffee now, but maybe more drinks later on. So come back in 5 minutes, please.
Warum lächeln Gold?
Every little sign, every little symbol.
About climate and awareness. So next presentation will be given by Anastasia Bubko, an integrated system for monitoring the effects of climate change on the monuments of Delos.
So good evening. My name is Anastasia Pupko, and I am an atmospheric scientist. I am a researcher in the Research Center of Atmospheric Physics and Climatology of the Academy of Athens. I'm here to present you an integrated system for monitoring the effect of climate change for the monuments of the island of Delos. It is a project that has started to be running 6 months before with the collaboration of many different institutions. However, the major effort is from the Academy of Athens and from the National Observatory of Athens. This project has been funded by benefit foundations of Greece. Why we focus on the island of Delos? Delos is an UNESCO World Heritage Site. It used to be a very important religious center in the ancient world and a thriving Mediterranean port until almost the 7th century AD when it stopped to be inhabited. Over the island, we can find different kind of monuments related, of course, with everyday life, with religious activities. There are temples, sanctuaries, public houses, residential houses, warehouses also. So there is a variety of different monuments that exist in the island. Also, Delos is a small island in the middle of the Aegean Sea. There, the meteorological conditions are very specific, and the island is exposed to different atmospheric masses that are coming from the Western, the Eastern Europe, but also from Africa. Dilos is one of the 13 monuments that have been undefined as extremely endangered by the climate change. This was, in fact, analysis that we have already published in the literature by my colleague Kapsomenakis Ioannis. You see many different, many monuments in the Mediterranean area, in the European countries of the Mediterranean areas. Some of them are in Spain, in Italy, in Croatia, in Albania, in Turkey, and of course in Greece. And Dilos is one of the islands that are expected to be severely affected by climate change. To arrive in this map, we identified different climate hazards associated with extreme phenomena like extreme heat, extreme fire weather, extreme precipitation, aridity, frost, and sea level rise. We expressed these extreme hazards with indicators which were combined with the seismic hazard to arrive in a synergistic and unified index, which is called the Heritage Hazard Index, and which allows the ranking of the monuments with respect to the hazard from climate change and seismic activity. You can see a map that we have compiled for two different climate scenarios, the RCP 4.5 and the RCP 8.5. It has been found that Dilos is mostly affected by sea level rise and extreme precipitation, while seismic activity and also aridity are also important climate hazards for the monuments that exist in the island of Dilos. In fact, the impacts of the climate change are already evident on the island. You can see some photographs taken in the beginning of the 20th century, and you see similar ones recent years. In the year 2015, you see that the land has already recessed, and of course, many of the monuments are now flooded. So action is also necessary, and monitoring of the monuments and of the island in general is a necessity. In the project that we are running, we are using different scientific tools to monitor the effects of climate change on the island of Dilos. These tools include climate change analysis, atmospheric, sea level satellite, and seismic monitoring, in addition to high-resolution environmental modeling. Just a few words about this project that started 6 months before, so it's more or less in the beginning. The climate change analysis that we have started to perform is based on the ensemble of climate models as these have been already applied in the framework of the Eurocortex program. These climate data have a spatial resolution of 10 by 10 spatial kilometers squared, but they will be statistically downscaled so as to arrive in a spatial resolution that will be 250 by 250 meters over Dilos. We will be studying 3 30-year periods, one presenting the present climate and 2 additionals for the near future and for the near climate and for the far future climate. We perform the analysis for 2 climate emission scenarios. The RCP one is the 4.5, which is a moderate mitigation scenario, and the second one is the business as usual scenario named RCP 8.5. Different climate hazards will be estimated and will be combined with the specific properties of the monument and with the geological features of the island, so as to try to understand the vulnerability of the monuments in the island and to result in some proposed actions for adaptation to climate change. With respect to the atmospheric monitoring, in the island, there is already a monitoring station and also an air pollution station, but this infrastructure is expected to be extended. So additional meteorological station will be installed in Delos, but also in the neighboring islands, in the island of Mykonos and in the island of Rhenia, so as to provide a more complete, let's say, picture of how the meteorological conditions in this area are. Also, an air pollution monitoring system, as I told you already exists in Delos, but a new one will be installed in Mykonos. This is mostly because the island of Mykonos is a top touristic destination, attracting millions of tourists during the warm period of the year. And of course, as you can understand, there is an intense ship traffic, passenger ship and cruise ship activity, and we would like to understand how these emissions may affect the monuments in the island of Delos. Of course, sea level rise is the major, I would say, problem, as I have showed you before in the island. Piezoelectric tide gauge and a global navigation satellite system will be installed in the harbor of Delos, in addition to a radar-type tide gauge that will be placed in the harbor of Mykonos. This instrumentation will allow us to monitor the relative and absolute sea level rise, and also the changes of sea level because of the tides and because of the storm surges. Of course, satellite monitoring is very important in the integrated system that we are developing. You can see on the slide different variables that is related with the impact of climate change on the monuments of Delos. So long-term satellite data, long-term records will be derived, and we will develop also a database with data for the sea level, precipitation, air quality, mostly nitrogen dioxide, sulfur dioxide, ozone and particulate matter, dust, and also UV radiation. Of course, these long-term records will allow us to understand better how the spatiotemporal variation of micrometeorological atmospheric chemical conditions are in the area, and this will assist the managers of the monuments for long-term planning, while at the same time the real-time evaluation of the atmospheric condition will facilitate short or medium-term planning. Of course, as I told you before, seismic hazard is an important hazard in the island and generally in the Eastern Mediterranean. Two seismic stations will be installed, one in Delos and one in Mykonos. This instrumentation will allow us to have more information about the seismic activity in the island, about the microseismicity, which is related more or less with fault zones that exist in the area, for which we need to have more information. And also we will get information about the seismic activity related with natural and human phenomena. This will be done through ambient ground noise analysis. Finally, alerts will be issued and provided to the authorities and also to the visitors and to the local authorities of the area. These alerts will refer to extreme meteorological, chemical, and events, and extreme also wave activity. For this reason, the WRF meteorological model and the WRF chemical model will be applied over the island with a very high spatial resolution of 1 kilometer, while the SWAN wave model will be applied with spatial resolution of 500 meters over the greater area of Delos. Of course, what I have shown you up to now, it's only one part of the whole procedure. We need collaboration with more disciplines. We are already collaborating with the local archaeological service, which is responsible for the management of the monuments in Dilos. The archaeological service is already taking some actions to protect the monuments. You can see that there is a relocation of marbles in other places in the island, or even some of the marbles are placed in the museum that exist on the island of Dilos. While in some cases some platforms are being placed so as to avoid the impacts on the marbles because of the sea level rise. The data that we will provide will be available to all the authorities, local, regional, and national ones. And we will prepare a platform that will be, where the data will be open also to the scientific community and to the different national and international scientific networks. We hope that this pilot project and this integrated system will be replicated to other monuments all over the world. And with this project, we are also joining one initiative of Greece at the United Nations level. It is an initiative which is called Addressing Climate Change Impact on Cultural and Natural Heritage. It has been launched in the year 2019, and it is implemented with support of UNESCO, of the World Meteorological Organization, and UNFCCC. Up to now, it has a support of more than 100 UN members and support from national and international organizations that some of them you can see them on the slide. It is also, for example, ICOMOS and Europa Nostra. This is more or less my presentation. As I told you, it is only 6 months that the project is running, and I hope in the next meeting I could show some real data from the monitoring system that we are now developing. Thank you.
So we have time for one quick question. No question, then thank you for the presentation. We move to the next one.
The next topic is hydrogeological risk using remote sensing and geological analysis in the ancient city of Gabi. And I have the honor that Yolanda Patrono is a co-author of this paper. Please.
Thank you. I'm very pleased to be here. Good afternoon to all. I am Emiliano Tondi, researcher in archaeology at the University of Rome Tor Vergata. First of all, we want to like to thank Rocco Buchicchio and Chiara Andreotti of the Special Superintendents for Archaeology, Fine Arts and Landscape of Rome for supporting the start of this project, and Martino Almonte, current director of the Museums and Archaeological Parks of Praeneste and Gabi, to continue enthusiastically supporting this research. The archaeological area of Gabi, that is just here, a few kilometers from here, maybe you can see it from the terrace if you know where to see, is an excellent example of an ancient settlement near Rome, acting from the Bronze Age to the Medieval Age, mainly located along a ridge of tough rock that bordered an ancient lake. All this area is relevant for paleoenvironmental reconstruction, geological analysis, and historical events. Boreholes were drilled down in recent years in the ancient lake, and pollen and geochemical analysis results were presented in many references by many researchers. The lake is a crucial source of information about the paleoenvironment on this central Italian region. This analysis offers insight into climate change over the past 350,000 years. And it is about 350,000 years ago, according to the latest data, that a pyroclastic ground surge erupted from the Castiglione crater, depositing a layer of ash, crystal, glass, and fragments of lava and other rocks in an area around the crater for more than 1,000 meters. The structural and textural characteristics are typical of the products of phreatomagmatic activity with the depositional attributes of a base surge. The maximum thickness of the formation reaches 60 meters. The extinct volcanic crater hosted a lake named Lago di Castiglione in ancient times, and it was then drained by the reclamation work carried out by the Borghese family in 1890. The resulting pyroclastic rock, known to the Romans as lapis gabinus, is sometimes characterized by alternating coarse and fine-grained layers, which can easily be distinguished microscopically if present. The stone is also strongly grains-supported and cemented with white zeolite cement. The aniaxial failure stress for samples of this rock, caught in Gaby, reaches values of 25-29 megapascal. The abundance of rocky material made the lapis gabinus a strong and durable stone, widely used by Roman builders. The most symbolic monument built in the lapis gabinus technique is the Temple of Juno Gabina, dating back to the 2nd century BC. And it has been a reference point for this sector of the Roman countryside for centuries. Other important monuments in Rome were built using this rock: the Tabularium on Capitol Hill, the Forum of Augusto, and Pompeii's theaters, to name just a few. Gaby is a city highly connected to historical events linked to the monarchy's fall in Rome in the 6th century BC. Many international archaeological missions are interested in investigating the site, from the University of Michigan to the Louvre Museum, just to say some, and of course, the University of Rome Tor Vergata, represented by Marco Fabbri and Emiliano Tondi, involved in this presentation. Our topics are focused on 2 cases settled in the north part of the site, the so-called arcs, the highest part of the city, case 1, and an open area not yet investigated by archaeological diggings, case 2, on which we will present some preliminary results of ongoing research. During the excavation campaign in 2012, the evidence of a soil fracture in the archaeological area of the arcs was registered. It is worth mentioning that the fracture stands over an unstable area, the ancient city perches on the slope of the Lago di Castiglione. In 2024, we measured the max height of the fracture at 0.5 centimeters in the north part of the arcs, and 3 centimeters in the south part of it. So we decided to investigate this phenomenon through a multidisciplinary approach. To investigate the origin and the movements of the soil fracture in time, we performed a multi-temporal analysis starting from the values recorded on EGMS, the European Ground Motion Service, a Copernicus service that provides consistent and reliable information regarding natural and anthropogenic ground motion over the Copernicus participating states and across national borders with millimeter accuracy. The scope is to quantify this movement over time, preferably until the most recent. Because the EGMS didn't provide motion information after 2021, it was decided to use on-demand available services on the Geohazard Thematic Exploitation Platform, GEP, that allows us to use services using the same advanced techniques but covering from 2016 to 2023. For that purpose, the snapping services IFG and PSI Full were selected, as they provide the finest deformation information with its time series evolution, similar to what can be obtained by EGMS. This analysis has been possible thanks to a sponsorship request through the European Space Agency Network of Resource Initiative. The Sentinel-1 data covers the period from May 2016 until May 2023, ascending and descending tracks, using 1 image per month, 85 in total, despite a more frequent data availability. The final step is to derive also the up-down and east-west deformation to understand whether the movement depicted from EGMS data varied, accelerated or decelerated during the last couple of years, as the last period of the EGMS data indicated a potential change in the deformation trend. We noticed a slight east-west and vertical movement on the ground, corresponding at about 2.660 millimeter per year and 0.8 millimeter per year, respectively. Special Superintendents for Archaeology, Fine Arts and Landscape of Rome in October 2023 installed the physical monitoring of the lesion by placing 2 crack meters, which we will call crack meter A and crack meter B. Crack meter A is positioned in the north sector of the fracture. It measured the movement of 0 millimeter in 1 year. It has been a preliminary good notice that is not supported by crack meter B. During the same period, crack meter B registered a movement of about 2 millimeters. So we can observe different movement in 2 parts of the site at about 4 meters from crack meter A to crack meter B. To explain this phenomenon and better understand what is going to happen on this hill, we like to use the metaphor of a piece of bread torn with your hands. But I think the picture is worth 1,000 words in these cases. Some final consideration can be made about this fracture. We can try to reconstruct its age using this data, but it is pretty impossible because the speed of the fault separation hasn't been constant in time. In fact, we checked an acceleration during the last few years. If it wasn't, starting today from a 2.6 millimeter per year movement for an actual max height of about 3 centimeters, we obtained that its birth should have been about 11 years ago, in 2013. But it was seen in 2011, 2 years before. So we can just assume that this is a modern fracture, maybe not older than 20 years. We can try to register more detailed data using VHR-SAR. Still, maybe it is now more critical for the site to start a recovery-oriented program made by a first step of mitigation and covering the area to prevent the rain from falling inside the fracture is just the first idea. And the final step of consolidating the slope. In every case, it will be an expensive and challenging project. How much time do we have before the detachment? We cannot know, because this phenomenon depends on so many factors and data that we don't have, and it is pretty impossible to say anything about it. Very quickly, just some words about case 2. Case 2 is at the same archaeological site, but a bit more east, in the area highlighted in the slide. This area is inside the ancient city, but it is not object of archaeological excavation, so we can just suppose what is hidden under the grass. The idea started after a significant wildfire event in August 2020. These fires have been occurring more and more frequently in recent years. Although it has been verified that they are primarily criminal or otherwise caused by human actions, they are certainly favored by vegetation that must face increasingly long dry seasons due to the ongoing climatic changes. The fire interested a large part of the ancient city, involving the structures of the famous Temple of Juno Gabina, which fortunately had no structural damage. We first applied the SSIM algorithm to detect areas affected by the fire. The vectorization of such an area on GIS software reported an extension of about 45 hectares. The east sector of the site captured our attention. In this slide, we show a Microsoft Bing map captured after the fire, in which the Case 2 area shows many alterations in burnt vegetation. Most of these signs are probably agricultural ones. Maybe some are about no more existing trees, and some have other explanations. But our interest is focused on more than just this topic. We're also interested in analyzing areas where signs became evident after an exceptional event. Can we recognize these signs in data from satellite images or vegetation indexes before or after the event? Can we match these signs with other non-invasive archaeological research, such as magnetometry, LiDAR, resistivity, and GPR? In other words, can we benefit from a terrible event like this? We are analyzing data collected by both Sentinel-2 and multispectral drone and comparing them with data coming from edited studies, historical images, or archaeological non-invasive survey activity. As a multidisciplinary team of engineers, archaeologists, and geologists, we apply a multidisciplinary approach. We aim to train an AI not only to recognize anomalies in satellite data. This is an obvious opportunity. We are trying to detect signs we know could exist because of another type of study, such as the ones shown above. In some ways, we want to train an AI to identify some that cannot be detected in optical analysis or multispectral indexes. The aim is to report all these results in an integrated, interpreted map showing an archaeological landscape where future digging campaigns can be planned. Linking extraordinary events due to climate change with new research opportunities is a twist of the unexpected coin, a cynical but a real opportunity given to those who, like us, have been experiencing this phenomena since the beginning of their appearance, placing us in a privileged observation position. Thank you.
Sorry, but we don't have time for questions.
Yes, so we move to the next presentation given by Marco Fiorucci about detecting, analysis, looting activities using LiDAR and machine learning, the Optimal project.
Okay, thank you. Today I'm going to present the main output of the Optimal project, that is a Marie Curie Fellowship individual funded by the European Union. And thanks to this project, I spent 1 year at Kyoto University, and so it is a joint work. And here I just like to mention some of the collaborators and the references. A slide you will see the whole team. Okay, so the main goal of the Optimal Trust project is to develop a machine learning-based approach to identify looting automatically and without requiring labeled data. So, okay. So looting, as you know, is the legal excavation of archaeological sites to collect historical material. And it's a pressing problem at global scale. Why? Because, of course, it caused the destruction of our cultural heritage, and not only, because there are several reports that, unfortunately, stolen artifacts fund terrorism activities. So this call for the development of efficient way to tackle down looting, and unfortunately, the most part of loot happened in a war zone or in area covered by vegetation. In the Optimal project, that stands for Optimal Transport for Identify Murder Activities on LiDAR, we tackle this challenge. Okay, so why LiDAR? As archaeologists, you know that LiDAR is, widely used in archaeology because can allow us to see under canopies, because can penetrate canopies, and then it is used to strip it down canopies to find archaeological structure. And for example, here, it is an area of Cambodia, Kulen, where they discovered awesome temples. And how we can detect looting? Thanks to Damien, I have a bitemporal pair, so two campaigns, okay, that are collected over 3 years on a wide area of Cambodia. And basically, okay, how we can detect, how we can train and machine learning to detect looting. As you heard, by previous speaker, there is this framework, change detection, that aims to find difference in altitude, positive and negative. So negative, there is a looting pit on LiDAR point cloud. Okay, so if in ideal world the 2-point cloud are perfectly registered, so the change detection is trivial. Just like you can compute a sort of distance for each point of the first cloud to the second, of the corresponding registered point of the second cloud. Yeah, but as you know, there is quite often, if not always, unmatching spatial support because the two campaigns are collected over different years. Maybe there are different sensors, so different also point density. And moreover, if you want to train some supervised machine learning approach, you know that you have to label it, in this case, millions of points, and so it's really time consuming, it's a nightmare. So for these, so Optimal just try to tackle these two challenges. Optimal stands for Optimal Transport for Identified Looting Activity. And so basically we developed two unsupervised methods, where unsupervised, it doesn't mean that it does not require labeled data. And that are based on two frameworks that I am going to present: optimal transport and implicit neural representation. The study area, as I mentioned, is Kulen area in Cambodia. And there are some temples that are already looted. The first approach is optimal transport. So just like to give a really intuition behind that. Why transport? Because if we think the first point cloud, okay, that now from now on we call red cloud for simplicity, and is the cloud that are collected and given here. And then the blue cloud is the target cloud, so the cloud that is collected maybe after 3 years, like in our case study. So the transport, it does mean that there is a match. So for each red point, we have to match a blue point. But of course, there are, a lot of combination of matching, okay, a lot of matching in principle. But why we use the word optimal? Optimal in terms of a cost function, where a cost function is just like a way of saying, okay, for example, how, since the LiDAR point cloud lives in our 3D space, so we use just like Euclidean distance. So how far is 2 points, and this is the cost. So on average, we want to minimize this transport. Basically, very quickly, just like this is a minimization problem. This is here the terms are, here is, it is called a transportation plan. So it's a matrix where each entry tell us the amount of mass, I mean, how the mass that is transported from a red point to a blue point. And then the cost in this case is just like how much I have to pay to transport a unit of mass. If we multiply how much I pay for each, for example, each unit times the amount of mass, how many units I move, so I have the total cost. And if I sum up for all the points, because here the cost is, sorry, for only one point, but if I have to consider all the red point and all the blue point, I have the total cost that I have to pay to move all the points from the red one to the blue one. And so briefly, this is the high-level algorithm. So the first step, we want to solve this minimization problem. So we want to find this big pie that minimize the total cost, let's say. And so when we find this transport plan, so okay, point in one location is mapped to another point in another location, and so on. So we can project the two clouds, and this it allows us to register the 2-point cloud. So basically, all these framework able to co-register the 2-point cloud. When they are registered, so we just like compute the distance as, point-wise distance. Here it is a qualitative result where yellowish doesn't mean more yellow is more intense is the change. And as you can see here, we can find 2 looted temples. And, but at the same time, we detect a lot of false positive, okay? Because a lot of area are yellowish, but are not looted temples. So the pro of this method is that since it is applied on point cloud, so they preserve the geometry of the looting pit, not only the diameter, but also the depth of the looting pit. But at the same time, it is not so precise. And so for that reason, we develop a second method to improve the accuracy of the first methods. And here, no math is involved, just like intuition. Here we have the 2 clouds. And here there are, here for simplicity, we just like show a building, okay, two kind of building. And these tools that we develop is use a neural network to interpolate among the point and to reconstruct the shape that the point cloud is captured. So for example, here you can see in the first cloud there is the blue shape, the second cloud the red shape that resemble these 2 buildings. And these methods, again, it is useful to register 2-point cloud, but not only, because since we reconstruct the shape, so we can think as super resolution method. We super resolved the point clouds, because now we can sample in whatever location we want. And here, just like we want to assess quantitative, if the second methods improve also the accuracy, not only qualitative. And so for that reason, we unfortunately we don't have a labeled, couple of point cloud data set for looting. And so we have to we have to use a simulated airborne LiDAR point cloud for change detection dataset on urban exploring. So there are new buildings are constructed, buildings are demolished, and so here is we want to detect change in building. And here there are some measures. And we see that in the last column, our method beat the other method. And also, in qualitative, from qualitative point of view, there are not only able to identify looted temples, but also when there are false positives, there is a post-processing approach that filter out post-processing based on the diameter. For example, here the diameter of on the top right corner is just like 20 meters. So it's really difficult that a looting pit has a diameter of 20 meters. To conclude, we developed two unsupervised change detection methods on point cloud for identify looting activities. We plan to, in the future, we plan to combine the best of the two worlds and to improve more the accuracy. And of course, if some of you is interested in some collaboration and have some data set on point cloud for looting, okay, I'm happy to apply our method on that data set. And thank you. Here are the references. All the code are open source, so you can just like, send me an email, and I'm more than happy to share the code. Unfortunately, I can share the dataset because the Cambodia government, does not allow to share the point cloud. So, thank you.
Again, no time for questions, sorry. The next paper is on a platform for the visualization and analysis of heritage data to be presented by Visioterra. Serge, please.
Hello, everybody. Okay, it's fine. Thank you. And we present a platform, EDAVI, that has been developed for 10 years ago, and we are across several projects. And now we have in a project in which we develop always more views, and depending of the public with Discover and also Explorer. Next slide, please. So I will shortly, next slide. I don't know, do I have to, okay, myself, okay, next slide is here. Okay. Okay, just a short agenda. I will present my company, Visioterra, the VTWeb platform, and also EDAVI with the two versions, Discover and Explorer, and 3 examples showing how we compare the heritage data to the Sentinel data. So we'll also show not only for radar data, but also for optical data. Here on the right, you have 2 views. The first one on the upper right is for the Discover, and for the Explorer, for more skilled people, is the second one. So my company is Visioterra. We are a French company located 15 kilometers east of Paris, and you have some numbers showing you are welcome here in Paris. We are, for Italian, it's better to say not 15 kilometers of Paris, but 15 kilometers west of Euro Disney. And we are working, we are very proud to be also to have the label of Copernicus Academy, but also we work in many projects in Africa to help people to manage projects on the Africa continent. So VTWeb is an invention we have done in the sense that we have seen that people have difficulties to get the data. They are too heavy, the protocol is complex and so on, and the format. So we have tried to make something easy for them to use to access the wealth of data that are available, free data across the web. So we have set up our own cloud, our own infrastructure called VTWeb, in which we manage all the things that are complex here. And for the clients here, VTWeb clients, Google Earth, some GIS and so on, we enable people to easily access and to order products and to see them, to compare them, to analyze them. So we try to answer to different questions, and our scope is to make the data available for citizens and scientists. And here you have the URLs of the two platforms that have been developed. The first one here is Discover. It's very easy to discover the data through different stories in which you can see in the past watching for ERS data, and VSAT MERIS, and VSAT ASAR data, and up to Sentinel data also, and to compare these data. And for more skilled people, as I told you, we have an Explorer in which people are able to set their parameters for processing on the fly. What we do, we believe that we have invented many complex, for example, POF-ML, that is a processing on the fly macrolanguage, also some hyperlooks enabling to, with a simple URL, a rich URL, to access to processed data. Let's go on the first example. Here you are in Sundarbans in Bangladesh, and this is very old data from ERS SAR data, in which you can see the mangrove, the location, and the kind of in situ data you can have. And here this is radar data with a single VV polarization. And after you have MVSAT ASAR data, Advanced Synthetic Aperture Radar data, that has been collected more than 10 years after, in 2004, more or less at the same location, but not exactly on the same footprint, as you can see, because I have reported the footprints of the three acquisitions I will show you. And the last one is the Sentinel-1 data that has been acquired last year in November 2 in 2023, and in which you see the colors because, as you know, you have two polarimetry bands, and with the VVVH. And when you combine these data, the first challenge is to superimpose these data. So we have set up auto-rectification on the fly of SAR data. Here you can see, for example, with the multi-date color composition in 91 in red, in 2004 MVSAT in green, and 2023 Sentinel-1. The first one was the RS1. You have this kind of synthetic images in which you can see that some islands has been eroded. Some over you can see that some accretion of data along the coast. So all these things are obviously due to the subduction of terrain, and there are moving terrain in mangrove. Another example here in Indonesia, in which you can see, or don't see, in fact, all these things are forest. Unfortunately, you have mountainous area, and you know the problem with radar data, in which you have to stretch the size to be to set them in the geodetic reference system here. And these are RS1 data that has been acquired in 2000. Here, MVSAT ASAR data, more or less the same. Here you can recognize more or less with some habits the the forest, here the cities, here an airport. And here, for Sentinel-1 data, you can see something that has not been detected in the past, something important, also in Africa, in which you can see some deforestation that has been performed here in a normal national park of Kerinci Seblat National Park in Indonesia. Last example is Mont Saint-Michel. You are welcome to come in France. It's a more visited place in France, Mont Saint-Michel, good for love. Lovers are always going in Mont Saint-Michel. And there is a very important issue in France because with the sand, you have a deposit of sands, not sands, let's say, the boue, in which it's not anymore an island. And this occurred 15 years ago, in which some accumulation of ground made this island disappear, in the sense that it was directly or permanently connected to the continent. And a project, a very expensive project, has been set up in France, in which they have built here some dams releasing water and controlled waters to manage the water streams here in order to make this island still an island. So in RSR in 91 it was not the case, and you can see that here, the Mont Saint-Michel, you have only one corridor of a stream of a small river arriving here, controlled by dams. In 2009, something else, it's not ESA mission, this is a contributing mission that is Japan ALOS-1 PALSAR data, in which quadrupole, three polarimetry has been collected here to compute this color composite. And it's clearer the way you can see here the Mont Saint-Michel and the corridor here of this stream. And finally, with this dam, with some work that has been performed, they have constructed a second stream here, and to enable to keep this island with high water completely disconnected from the land. So you see this kind of application across the time, and of some sites that are very important. Alors, we don't manage only radar data, we manage also, for example, making the comparison between the Envisat MERIS data versus OLCI, Sentinel-3 data, in which you have many examples. All these examples are hyperlooks, in which when you will access to this presentation, you have just to click on this and you will be enabled to navigate inside the image, zoom, dezoom, and so on. So here you have different views of MERIS data in a zone, for example, of deforestation in Amazonia, in which you can see, obviously, the deforestation. And many other examples like the Aral Sea and regression, Grand Canyon, phytoplankton blooms, and so on. So many stories that enable you to compare the past and the present. Scope all these EDAVI projects, and to show the skills and the experience of Open Space Agency, in particular for radar data processing, and to show the continuity and to understand why Sentinel-1 data has been the success of Sentinel-1 data today. For the technological success is also an heritage of all this experience. And also the fact that it's good for, as you imagine, for training, to train people to understand the behavior, and the interest of managing, monitoring their area of interest. For example, in Africa, we manage deforestation, in particular in the Congo Basin, and we are using many heritage data acquired by ERS and VISAT data. Thank you for your attention, and my colleague Guillaume Morel is here, and I'm here, Serge Rezanov. Thank you.
Thank you for the presentation. We move to the next one. So, closing the knowledge gap, vocational training about EU services and cultural heritage preservation, given by Karin Nurkakun. Please.
Yeah, thank you very much. It's been a long conference day, wasn't it? And we are in final sprint now. But during the whole day, we have traveled the world, we have traveled space, and now we are getting back to the ground. We are getting back to Europe. And we are getting back to the basics, the absolute basics. And the basic, in order to use all these wonderful data, all this wonderful project, is skills development. And this is what the SATCULT project is about. I'll give you a very short summary. Cultural heritage, we learned it today, is facing risk from climate change, from natural hazards, and also from war destruction. War destruction was not so very much a topic today, but it will be a very huge topic in the future, as we can all imagine. Earth observation data by satellites can help to prevent and mitigate risk, and the majority of the workforce in cultural heritage is not prepared for that. And there is a lot of training still necessary in order to bring the people to benefit what we have learned today. And SATCULT is the project which will prepare the workforce for that. We are co-funded by the Erasmus program, and not by the academic Erasmus program, but by the vocational training program, which means we are coming to the ground, where the people need the training on the ground. And what is maybe interesting for you, at least for those from the heritage part, you might know the big Charter project. Charter is at the moment the most important project of the European Commission for skills development in the heritage sector. And I'm also a partner, a full partner in the Charter project. And I really recommend you to go on the Charter website, because here we are identifying the skills, the future skills, and what we are doing here and what I'm doing now in the future with the SATCULT project is exactly that. This is the skills we need. And who we are a very small partnership for very good reasons. There is my company, we are a social enterprise. I'm an art historian from education, and we are the experts for the training development. Then we have the CNR, the Italian, who are with their department of the cultural heritage included. And we have the partner from Cyprus, Eratosthenes Excellence Center. They are going to provide us with the necessary knowledge on Earth observation. We have not started yet, but I'm still here, because when I saw this conference, I thought, my God, this is the opportunity of my life, at least of the project life, and thank you very much for inviting me. So the background, already today it was Alessandro, I think. He already told us about this really important, well, for the heritage sector, important OMC report on strengthening cultural heritage resilience for climate change. And Johanna Leisner, who did this report, she is also a partner. She is going to work with me in my company for this project. We are very grateful on that. And Johanna, she wrote in this report the essential sentence: the European member states do not have proper policies and action plans in place to mitigate threats from climate change on cultural heritage, nor does the European Union. And this is, in the end, the final background, the most important background for the SATCULT project. So the report pointed very clearly on the potential of using Earth observation data in cultural heritage. And the report also said the sector is not prepared for that, and they urgently need the training in access to the relevant data, in the analysis, and how to use the data analysis. Yeah, this is nothing we've ever learned, how to analyze this data and to use it. And also in the supportive implementation of preventive measures, and the heritage sector will not be able to do it alone. And here we are back with interdisciplinarity again. We've heard about that many times today, and this is definitely one of the essentials, interdisciplinary working. So the SATCULT project, we will investigate and record conditions under which the heritage organizations can acquire the necessary knowledge, and the focus is on vocational training, people working on the ground every day, the heritage manager, the art historians, the conservatists. These are the people we are going to address. And we see our project as an opportunity to make staff, their networks, their initiatives in the preservation, and also their training providers, because you need people who transport the knowledge, to prepare the knowledge to be used, to make them aware of the potential of Earth observation data and translate it into concrete translation. I mean, this is also one of the core topics, how to translate, how to find the common language. And we have, overall, we have 18 months for that. We will have to be very, very quick, because we are only preparing the ground, and there will be a much bigger project which we are preparing in this project. Which will focus on a training curriculum, but not an academic one, maybe also an academic one, we don't know yet how far we get, but a training program which can be used all over Europe. So, first of all, we will identify the qualification requirements of the staff in public and private heritage institutions and site, because actually we do not know everything. How are the qualifications? Are there qualifications at all in our directions? We have to find out. Of course, our staff needs to be sensitized to the possibility of Earth observation. This is not a topic at the moment. It is a topic with the archaeologists. We learned this today also, and there are wonderful examples, but archaeology is such a small part of cultural heritage preservation. So most of the other people, they are not aware of that. And we will make a collection of examples of good practices which are offered by Earth observation. We will publish and we will disseminate them. And for that, I really ask for your support. I'll come back on that a little bit later, because we would like to identify the training needs by a survey, also by the heritage people, but also by people linked to Earth conservation, Earth observation, sorry. And we would like to bring this expertise from both fields together in one database, and prepare pilot sites for testing cooperation between experts from both sectors, and prepare in the end the development of an interdisciplinary curriculum. So, a lot to do. Let's start. We have to open up ways for accessing, analyzing, and using respective satellite and Earth observation data. We have 3 targeted groups. The biggest group, of course, are the heritage professionals in public as well as private organization. It's not only the public sector. We have a lot of private organization handling heritage and preservation activities all over Europe. We have very strong umbrella organizations, and this is the biggest target group. But also people like you, like many of you, researchers, engineers working in the sector of geoinformation, with the direct access to respective data, because we as a heritage people, we don't have this access, and actually we don't know how to handle it. So this is going to be what we have to learn. And of course, people like me, training providers who want to bring the information to the heritage sector. This can be staff at training academies of the monument conservation bodies in our 3 countries, but also to other training providers all over Europe, and also to the churches, because the churches are very relevant and very important for our work. And I hope that we can convince them to invest also in this kind of work. So I would like to invite all of you for participation. Of course, it's always a matter of network. So I want to be very practical, and I would be very grateful if you could give me your business cards. And if you don't have one, I learned today, not everybody has one, but it doesn't matter. I'm still one who is able to write by hand, and I have a notebook with me, and I would like to ask you to give me your contact details, because today I start to create the database. I have the database with the heritage people, 6,500 addresses. We have them, we have access. But the other side is not very much represented. So if you could give me your business cards, that would be really great. And we would like to ask you to forward good practices to me. I can give you my business card because I have one. And these good practices, I've already noted down the majority of those who have been presented today. But if you know more, send them to me. And it will be important for our database just to have these examples. As I said, we will prepare them in a publication, because the heritage people still read on paper. So we have to translate the information to their way of communicating, and there will be a bigger brochure on that, but we need the best examples of Europe. Not so very much of all over the world, but we want to have the European examples. Thank you very much, and it would be great to hear again of you. Thank you.
So I hope that thank you, and I hope that tomorrow we can have a discussion. Now we come to the closing paper, Enhancing Digital Geomedia Capabilities for UNESCO Designated Sites. It's going to be presented by Lars.
Yes, thank you very much, Mario. I'll try to be brief. I know it's the last presentation of the day, and we're all looking forward to drinks outside. I will be basically adding on what Karen just said. My name is Lasse Grimmer. I'm the coordinator of the UNESCO Chair on Observation Education of World Heritage and Biosphere Reserves. I know it's a mouthful, but we're located at the Institute of Geography and Geocommunication at the Heidelberg University of Education. So we have a very strong focus on the pedagogical and didactics approach to delivering geographical knowledge. And our 3 fields of focus are using, first of all, modern geoinformation technology, which is mainly represented by our GIS station, Center of Excellence for Digital Geomedia, and geoecological field and laboratory methods, where we have a Center of Excellence, the Gecko Lab, to analyze and communicate and sustainably develop UNESCO designated sites. And for that, we also have the Heidelberg Center on Education for Sustainable Development. The GIS station was opened in March 2010, and our 3 digital geomedia focuses are the remote sensing and satellite imagery, geographic information systems, and mobile geotools, GPS, and geo education. We trained so far over 2,000 trainee teachers and teachers at our Center of Excellence. We had over 2,000 pupils going through our workshops, and had over 1,000 events and 300 educational institutions over the years. And what we wanted to do is, also the presentation that I'm presenting here today, is to find out the specific needs of UNESCO designated site managers and specifically stakeholders with their regards to their state of knowledge on using digital geomedia in their everyday use. So that's what we conducted. And I want to give you a short overview of our preliminary results to that. First of all, our initial data collection faced a couple of challenges, and we explored multiple challenges to reach all of the UNESCO designated sites, so that is World Heritage Sites, Biosphere Reserves, and global geoparks. There are over 2,000 of those UNESCO designated sites worldwide, and we were able to compile a list, an email list of 1,400 of them. We individually searched all 3 websites of the UNESCO and clicked on every single one of them and copied out the email addresses, and then sent out our international needs assessment and received responses totaling 134 total. We have more, but our total responses survey are 134. The responses came from 42 countries, and as you can see here, mainly from Mexico and Spain, because we offered the survey in English and Spanish, unfortunately not in French and Arabic, which then mainly, as you can see here, is that a lot of those countries are not represented in the data set. And most respondents were affiliated with World Heritage Sites, and some of them with biosphere reserves and global geoparks, but also diverse professional roles were represented. For the frequency of using digital media, so there are a couple of questions we asked during our international needs assessment. Basically, the respondents that filled out the survey were familiar with digital geomedia tools, and the primary applications were included the visualization and change detection. About 25% stated that they use remote sensing tools daily or weekly, while GIS tools are more prevalent. And nearly half of our respondents state that they use GIS tools daily or weekly, while Google Earth, not surprisingly, has a widespread usage among all our respondents. Respondents feel more confident in GIS skills than in remote sensing and mobile geo tools, and commonly used applications include QGIS, ArcMap, and Google Earth, while other specialized tools are also mentioned. Then for more questions, we also asked the participants if they are interested in a training course, because our goal is to then create training courses for all UNESCO designated site stakeholders so they can use digital geomedia in their everyday use. UNESCO designated site managers face challenges in digital geomedia due to equipment and financial limitations. The data acquisition and knowledge gaps are significant barriers to effectively use remote sensing tools, but despite experience, most respondents seek further training in digital geomedia application, as is shown here. A high demand also exists for specialized courses on vegetation mapping and change detection in particularly. Respondents then also prefer in-depth training programs lasting 3 or more days over short courses, but as seen in the last diagram on the right, limited budgets also pose a challenge to training, and cost-effective solutions are essential, especially for the accessibility of the digital geomedia courses. In addition to the international needs assessment, we also conducted 2 pilot courses back in 2022. Those were conducted with partners in Malawi and Costa Rica through the Engagement Global program, the ASA program. And we had 4 students from Costa Rica and Malawi and Germany designing those courses in their countries. And in the background, you can also see the UNESCO Chair Heidelberg's corporations all around the world. The project, or the ASA program, through which these courses were facilitated, supports global interdependencies and the sustainable development. Additionally, cross-cultural exchange was a huge benefit to the program and enriched the course content and delivery with varied perspectives. The initiative also fostered international understanding, especially aligning with UNESCO's educational objectives, which is obviously a priority for us as a UNESCO chair. And it also highlighted the potential of international partnerships to enhance education and promote global learning. So the course implementation per country differed, obviously, due to the specific context. The courses aim to enhance the digital geomedia skills tailored to the local context in Costa Rica and Malawi. In Costa Rica, the courses were performed using a hybrid training model, while Malawi opted for an in-person course structure due to the infrastructure that was given there, mainly due to complications with internet accessibility. The Costa Rican participants were mainly from the National Biosphere Reserves Committee, while in Malawi they included members of the Man of the Biosphere program and local ministries. Both groups had limited prior knowledge, with Costa Rica showing slightly higher baseline understanding of digital geomedia when going into the programs. And the courses emphasized the practical skills in QGIS and mobile geotools with case studies for context. In Costa Rica, there was an online self-learning module and online support as well as face-to-face sessions, so a blended learning approach. And in Malawi, as already said, we had face-to-face teaching, individual support, and a written manual for self-revision due to the complications with internet access. The focus in Costa Rica was on data acquisition, land use mapping, and visualization, while in Malawi it was mainly the same, with a little bit more tailored focus on digitalization and field data collection. The courses, the pilot courses were, of course, also evaluated by our students, and also the first author of this paper. We opted for a two-phase evaluation process. And as you can see here, the evaluation shows significant knowledge increases in remote sensing, GIS tools, and mobile geo tools post-training. The follow-up evaluation was performed after 1.5 years and indicates sustained knowledge levels above the pre-course values. Caution, however, is needed. Non-respondents may have lower knowledge retention over time. As you can see in the bottom right corner, we didn't have a lot of respondents. The findings, however, still show a highly positive and enduring impact on participants' digital geomedia skills for future training refinement. In addition to the quantitative measurements, we also had some qualitative ones. Our follow-up evaluation yielded a mean score of 4.36 out of 5. For the training course, the participants, however, found the content challenging and suggested extending the course duration for better understanding. The e-learning modules that were used, particularly in Costa Rica, received praise, validating the effectiveness of the blended learning approach. The respondents reported enhanced understanding of biosphere reserves and improved data collection skills, and 77% recommended the software and skills learned to colleagues and other people at UNESCO designated sites. However, the training's ripple effect extends knowledge transfer and influences broader practices in UNESCO designated site management. The feedback from participants can be summed up into 6 key areas for improvement. The first one is duration and pacing. We have to think about extending the training to 5 days or space sessions out for better skill retention. Second, the skill level differentiation. We have to offer the courses for varying skill levels and advanced follow-up options for the people who are fast learners. And then third, the participant diversity. We want to expand the training to include field workers and other relevant stakeholders at UNESCO designated sites, and not only make it available for managers. We have to think about the delivery format. We received mixed feedback on the hybrid courses, but there's a need for flexible, tailored delivery approaches. Fifth, last but not second to last, we have to think about the training environment because the courses took place in the biosphere reserves, and for future trainings you might want to consider a more neutral locations for training to minimize the distractions from daily work. And then the technical considerations, as already talked about, We have to think about the slow internet issues, not only in Malawi, but in other countries around the world as well. And we have to improve the pre-course communication on equipment needs. And then our outlook and vision for the future is, why did we do all of this? The pilot courses and international needs assessment is because we want to create courses specifically designed for UNESCO designated site stakeholders and those who want to become stakeholders or work with those sites. And we want to use, again, blended learning approaches, and for that we have developed an adaptive e-learning platform that was used during the hybrid courses, during the pilot courses, and our remote sensing software that you can see in the bottom left corner here. If you have any questions about those tools, please feel free to approach me. And ultimately, our goal is to first create a summer school program for UNESCO designated site stakeholders so they can learn more about using digital geomedia and how it can help them and visualize, monitor, and sustainably develop their sites. Then we want to advance the Diploma of Advanced Study and ultimately create an international Masters of Science program for people to learn more about how to use digital geomedia in their everyday use for sustainably developing UNESCO designated sites. So if you want to be part of that, if you have any questions or if you have already done such things, I'm more than happy to talk about that just in time, and thank you very much.
So thank you very much. Exceptionally, I do have a question to all of you, and that is, would you like to have a drink? Dan?
Kann gesundes Essen ungesund für Ihre Zähne sein? Säurehaltige Lebensmittel können zu Zahnschmelzverlust führen. Mit der Zeit können die Zähne dünner werden und gelblich erscheinen. ProSchmelz schützt vor